Good morning, everybody. We'll get started in a couple minutes. Good morning, everybody. I see we've got about 50 people here in the chat this morning. Looks like there's about 23 people watching the stream. We had a pretty good turnout yesterday for our unofficial kickoff day. And we've got a pretty good lineup today. I'm excited about today's lineup. Good morning, Tyler.
Good morning, John and everyone.
So today, we'll do our quick intro this morning, and then we've got Michael Smith up for our first workshop today. Then we've got Chris Taylor with an in-depth analysis of a fish, the email kind, not the trout or salmon kind, I think. Then we've got Ron Werner for firewall and something about AI. So I'm interested for that. And then Kirsten Renner, who I talked about yesterday during the workshop, the best technical recruiter I've ever met. So that's going to be great. And then we've got Tom, the former chairman. He was actually on a little bit yesterday when I was doing some resume review stuff late. He will be giving a VA specific workshop around VA disability. And then we've got trivia with Zobes, and that's everyone can play along. You can win internet points for trivia, which you can spend at any internet facility that takes internet points, which is very exciting for everybody. It's sort of like airline miles. You never will have enough, and they're not actually good for anything nowadays, pretty much. So yeah, Tyler, how are you doing this morning?
Oh, I'm doing just ducky.
I have a
What
friend. I have a friend whose handle is Ducky.
Huh.
Like your pug, Ducky. It's like a whole
I
animal thing.
yeah. I am literally a pug in human form. Yeah. So thanks everybody for coming. Every year we put this conference on. Been doing it for 4 years, I think now. I keep changing the number probably. I'll get it right one time. But originally we just started as an informal group of veterans trying to talk to each other about cybersecurity, give peer support, collaboration, and it's definitely been a journey getting us here. We recognized earlier that veterans often didn't have tailored resources that fit in with their specific needs, and there were networking barriers and skill misconceptions that industry had about us. And now we've managed to come together and put on a yearly conference, and it's great. And Zobler does get all the internet points. But yeah, thanks.
Yeah, I mean, I think our community and the Slack is pretty unique from what I have seen. Because certainly the core principle of ETSEC is to try to help people in cybersecurity or those who want to get into the cybersecurity field. But there's plenty of other things that happen, and we've talked about that yesterday as well. But we might have some new people here today. So our Slack has plenty of non-cybersecurity channels. We've got a meme channel. If you want to discuss current events, there's channels for that. um, and then there's all like the niche things even within cybersecurity. So there's like data science, there's AI focused chats, there's a threat intel one. Some people have stood up more like regional ones. So like I think I was and maybe I'm still in one for like Baltimore, Washington D.C. area. There's a channel for other people that work where I work. So there's like the Google VetSec channel, um, and that has Jake in it, so it's obviously like the worst channel that you could join.
Oh yeah,
Yeah.
sure.
Um, and then like there's gaming. There's like some gaming stuff in there. I think there's like a workout fitness thing that some people are in. And then there's all the sort of like benefits that are just from the Slack from the volunteers, and we talked about this yesterday. So like the resume review channel. So yes, we had a couple of talks yesterday. One from Mark in the morning, and then the one I did yesterday afternoon. But at any point, you can go into the resume workflow channel and get lots of different people to give you their opinions and get some get some points of view from other people who've been hiring managers or program managers. We have a mentor channel. So like if you want a specific mentor, and then that's staffed with about how many mentors do we have? Like 80 people in there, something like
80
that.
last I checked yesterday.
Yeah, and these are just again volunteers from the community who see the workflow pop up. There's a new request for a mentor, and then someone will eventually sort of like take that person and reach out to them. Is there a tutorial for the different platforms on Slack? I don't think we have a specific Slack tutorial, but I bet there is a Slack tutorial. I bet YouTube has a Slack tutorial.
Yeah, I mean, if you go to slack.com and look for the quick start guide, there is a thing that kind of shows how to use Slack. Like, here, I hope this is the right link. Hopefully that works.
It's like Teams, but not integrated with your SharePoint in some terrible way.
I mean, it's like a chat room with a bunch of different chats you can join. And it's very intuitive, I think.
Yeah, I think so. It's like Discord, but made for people
But
who knew what
professional.
engineering was.
Yeah. So I mean, if you play video games online and you use Discord, it's going to be almost identical to you. It's just more like professional and corporate and less less video game stuff. And yeah, it's like IRC. I mean, you can't slap anybody with a trout, but it's pretty similar.
Um,
Is that an okay reference? Am I too old?
I know what you're talking about. I will never forget. I was working in Canada at the Canadian Security Establishment, which is like their very small version of NSA. And I had all my Merc screens up, like 14 Merc screens up on my second monitor. And the director, one of the very senior people, walked by and he was like, "How do you know what's going on all the time?" Man, it's just multitasking, sir. This is my job.
Yeah.
Hello, Taylor. That everybody say hi to Taylor, who is the oncoming benefits coordinator and is getting up to speed to help us manage all of the benefits that we pass on to you folks.
Yeah, it's a big job, and we are very appreciative of the support. Because man, I was not able to handle that by myself.
Yeah, there's a lot of stuff. There's a lot of responsibilities. I don't know. Maybe we could talk about that for a couple of minutes, Tyler, if you want to. Because
Sure.
yeah, go ahead. You can.
Yeah, so I mean, we're all volunteers, all unpaid volunteers. So it's kind of a situation where, like, throughout the day, I keep my VetSec Slack up, and I'll get, a dozen messages about people looking for something. It could be trying to figure out the right benefit, could be questions, mentorship, questions about workflows. You know, there's just a lot that can go on within an organization of 8,500 people, and even just distributing benefits, like going in and adding an email address. Like, it takes a minute to do. It's very quick, but somebody still has to go do it. And whenever you have so many people, the operation at scale, it just gets mind blowing how much effort it can take. Um, for like our IAM team, for example, I'm estimating that they probably spend 1 to 2 hours per day, every single day of the week, 365, just vetting people for membership. Because we get, I'm going to estimate about 20 to 30 applications per day, and that's day or night, rain or shine. There's always going to be applications in the queue, and somebody has to look at them and verify them. Many of them will be considered not acceptable. Either people that don't fit the criteria, or we've had some companies try to sneak some people in to try to siphon off the benefits. There's been all sorts of ridiculous things that have happened in the past. But all of our members that are volunteers, they definitely keep us running. And we thank Taylor for taking on the benefits part, because it's a lot of work, because a lot of people want a lot of things, and you have to figure out how to get them connected. And if you think about it, each benefit is the result of a series of meetings, a series of phone calls, a series of quests with another company trying to set up a partnership. And these partnerships, they don't just spring up out of nowhere. You have to start asking people. So we email companies, we call companies call us about something, and we do a Uno reverse and say, hey, I know you're talking about selling something to my company, but I have this charity. You want to hear about it? And that's actually how a lot of our benefits have come up. Just saying, hey, we have a charity that we would like to consider. Can you pass this on to your chief marketing officer? And that's how it goes. But it has definitely been an experience trying to keep all the plates spinning. Some months are better than others, and things come up in real life. So we always do request that you be gracious with us, because sometimes nobody's around. Everybody's busy with work, and no one can get to a request. So that's just the nature of an all volunteer force.
Yeah, and everybody has, like, besides their work, like, everybody has other stuff going on. Like, Tyler's been very busy outside of work as well. I just spent like almost the entire month in Kuwait for work. I extended there longer than I had originally planned, because we had an instructor who couldn't get his visa, and I was like, I have to be back by Wednesday. I'm running this conference. And the board has 5 official members, so we haven't really gone over that a whole lot yet, because we'll probably cover that tomorrow as well before the main keynote. But you've got Tyler as the chairman, Chair Pug. Let me restart it.
Can people hear us?
No, it's trying to go live. Hopefully, this is not a
It
big
says
problem.
you're live on Sage.
Okay. I'm still getting the going live message.
If anybody is in chat that can, oh yeah, Thomas saying audio just cut out and back. It says it's live on stage for me.
I'm going to restart on my end.
Okay, I guess it's just me. Can people hear me? Somebody please in chat. Chat, say, can you hear me? I guess not. Okay. Well, Michael says he can hear, but he's backstage.
Yeah. Yeah, I think we're back now live.
Okay, perfect.
Yeah, I was just saying, like, you've got 5 board members here. So you've got Tyler, he's the chairman. You've got me, I'm the vice chairman. You've got Alex, our treasurer, who is fully qualified for that role, having been in charge of government travel card programs. Then you've got Elliot, who is our secretary, and Warren, aka Resume Destroyer Fish, as the member at large. So those are the board members. And then we have a ton of other volunteers, right? We have talked extensively about the 7-member IAM team, which handles all of the requests. Just yesterday, someone needed their multi-factor reset, right? So we get that email. I send that to the IAM team. They disable that so someone can put that onto a new phone, right? So they're handling all of that as well and all the vetting of applications. We definitely get applications from people who aren't eligible to join as well, right? So they have to handle the applications where we respond that like you're not eligible, right? So like you have to be a service member to join VetSec and join the Slack, because our member benefits are for service members only. So like if you're just a supporter or a military spouse and you're not the service member, you can't actually become a VetSec member. So we handle all of that, right? We've got all the people in the mentoring channel, which is all volunteer. The people who do the resume reviews is all volunteer. Right, our new benefits coordinator, Taylor, that's a completely volunteer position. We have people who are going to start doing the women in cybersecurity coordination that I used to do for a while. That's all volunteer. So there's a lot of need for a large amount of people outside of just the board members to keep this thing going. And so like to run the nonprofit, right, there's a huge financial aspect as well, right? So like we have to have enough funding and sponsorship, right? So like we've had a few successes in the last couple of months, including the big Google one. So stay tuned for that, for all the benefits that'll trickle down from that grant that we got from them. But the partnerships that we have with the sponsors also requires work. Like there's a back and forth with Fortinet, right? So yes, people can join the boot camp, but like we need to be involved with that. And then Tyler will get an email to see if somebody is actually a VetSec member, right? So, and that's just one example of that, right? We're just this morning coordinating like potential like RSA stuff for next year, right? Because that's already starting to get coordinated. So there's a lot of stuff that goes on behind the scenes of every nonprofit, including this one. So yeah. I've helped out with some others as well.
Yeah, people have asked in the past, but every VetSec member costs us about $8 per year in overhead right now. So we have to go out and scoot around for some change to keep on paying the bills. We are a 501c3, and that has legal obligations, tax obligations, trademark registration obligations. We had an incident last year. Was it last year? Maybe it was this year.
This year.
Where, this year, where a company was impersonating us. We had to hire a law firm, send cease and desist, and all that type of stuff. So it's fun.
Yeah, so there's that. So like if you have a trademark, basically you have to enforce the trademark or you'll lose the trademark. So if that other company or some other entity is like pretending to be you're using your trademark and you don't send cease and desist letters and get a lawyer involved, you can potentially lose the trademark. Yeah, there is a way to make a donation, actually. I will get that link for you in a moment.
There was a question in the chat that was from a little while ago that said, do you ever have group talks live? And the answer is, for internal members, yes. Every Monday at 7 p.m. Eastern time, there is a notification in the announcement channel that says it is the official start of the huddle hour. And the idea is that every member is invited to join General Safer Work and join the huddle. And we talk about whatever. Staff members sometimes show up, and I try to come as often as I can, but I mean, I can't make it to every single one of them. Our EIN. I can find it real quick in my notes. No, we unfortunately we do not have Zoom anymore. That is part of that overhead cost that I was discussing. We lost our Zoom account, to be frank. So we just use Slack now because we were paying for too many things.
We got a few other minutes before we hand it off to Sam and Michael if anybody does have some other questions, though.
I've been trying to get us properly listed on the Charity Navigator website, but I still need to submit paperwork for that, I think.
Okay. What I will try to do here real quickly then before we hand it over, we'll keep an eye for questions, but I'd like to
if you're interested, I posted the link to our Charity Navigator page. It's like a independent rating system that tries to describe how good of a charity we are. So it has some metrics on there. I'm still working through giving them all the paperwork to show what our finance looks like and proof of culture type stuff. But it has at least a couple things filled out there. Anyone that can tutor on WebEx. If you're InvestSec, you could probably ask. They might want money for that. Mentors, the free type thing that we do is back and forth over Slack, giving advice. In terms of actual education and teaching, that would be something that you would have to set up. I'd be fine with you posting, "Hey, I'm looking to hire somebody for training," but we do not currently offer direct one-on-one tutoring. Unless it's "Hey, I have a question about a topic. Can somebody tell me about it?" And then somebody might tell you about it.
And a lot of times that happens in the sub channels too. Like if you had a threat intel question, go to the threat intel channel, or a data science question, go to the data science channels, because that's where the people who are into those specific niches will reside most of the time. Let me just go through here real quick and thank our sponsors this morning before we get too far along. So we do have the Meta CTF. They've donated the CTF platform for us, so they are a general level sponsor. That starts tomorrow, so you should start forming your teams if you're going to want to play. We have Falcon Ops senior level sponsor this year, so we're really appreciative of them. We need all of our sponsors to keep going. We've got 3 enlisted level sponsors this year: Clearbridge Technology Group, SysDig, and Cody Frazier, Marine Corps, he was here yesterday. I don't know if he's still here today, but I super appreciate that from Cody as well, donating as an individual at this level. Google has given us a 6-figure grant. This was a competitive grant process we got during Fleet Week, so we're going to have some more educational benefits that come from this new partnership and from this Google grant. We got a couple other just general VetSec, not necessarily conference sponsors, but that's Zscaler, Leidos, and Salesforce. So we're very appreciative of all their sponsorship as well. And then we've got all of our long-term partners that we've talked about a little bit: SANS, Cybrary, Splunk, Fortinet, GitHub, and the RSA conference. CompTIA, Cisco, Level Effect, Coursera, TechVets, Wisys, and TCM. And yeah. We appreciate all of our long-term sponsors. And that's the link to the CTF. I think it's been posted a bunch of times if you need it. That is it for that.
So I'll quickly answer Jason's question about what does the future of VetSec look like, which could probably be its own talk. And then I think that'll be the last question. So basically, right now, our main focus is kind of on internally leaning out our processes and getting all of our documentation and paperwork improved. We have a lot of legacy type stuff that has been built over the years that is not fully maintained and has either stopped working, isn't being cared and fed for, like different benefits that have bad coupon codes and bad workflows. So it's really about getting back to a baseline, keep the lights on level. And then in that, we have, since we have a new board and we all have a lot of energy because we're not all burned out yet. We're we're focusing on trying to reach out for like the higher tier grant requests, which requires us to do greater levels of paperwork. So like that Charity Navigator that I just shared is like a big project where we're trying to prove to a rate and a third party accountability and governance website that we are doing that internally. So we have to actually do that internally. It can't just be 5 dudes in a Slack. It has to be the board. We have to take meeting minutes. We have to have a code of conduct. We have to have an internal code of conduct. We have to have financial processes, like you're familiar with GRC requirements. We have to have all the corporate requirements. So it's like, instead of just 5 dudes in a Slack, we have to actually write down our financial accountability requirements and then follow them. It can't just be, oh yeah, I'm just going to use Tyler's VetSec bank account credit card. It needs to be, no, we need to have a meeting. We need to have receipts. We need to have a storage mechanism. It's just getting all that higher tier corporate requirements so that we can get the higher tier grants, like the Google grant, for example. There was a I'm not going to say too much about it, but there was a grant we missed out on this year because we just didn't have that level of detail whenever the potential sponsor asked us for it. And it was like, well, we really need to get that, because they were asking about some percentages and metrics. And it was like, oh, I don't have that.
Right.
I'm just a guy.
Yeah, even when Google came back and we were doing the final negotiations for the legal grant, they wanted metrics. So like I ended up trying to pull some stuff together for them for that purpose. But it's really hard to measure impact. So the other thing is that's really helpful is like when Tyler pings everybody with questions or like needs you to fill out a survey. Like a lot of the reason we need that engagement from everybody who's active in the Slack is we're trying to get metrics, because a lot of people who want to give us money are like, how many veterans have you helped get a job? And if we only get like 100 people and 17 of them say that it's helped, then that's not a good percentage, right? So like that's why we are trying to build up some of these numbers sometimes as well. And then like even like the tracking for the new Google grant system for some of these benefits, like I've created a whole new, right, with all of my financial planning acumen as a threat intel analyst, like put together like some tracking mechanisms, because we're going to have to track how that money gets spent, because Google requires that tracking mechanism as part of the grant process. So we definitely want this money. It's like an amazing amount of money they have given us, but we have to go through all these processes to keep track of it so we can pass the benefits on to all of you. Yeah, I mean, I don't know. There's not a whole lot else. We could start to bring Michael and Sam up here and get them going. Oh, there's event chat too. So there's 2 chats. There's event chat and there's stage chat. So it's hard to see everything that's going on all the time. All right. Any other final questions before we bring Michael and Sam up here? I'm not seeing anything. All right. Let's get ready to rumble. All right. Sam and Michael, I'm bringing you guys on stage.
All right.
Hello.
Hey, good morning.
Sound check.
Good morning.
Video I see. Sound check.
I've got sound from both of you. Yep.
Outstanding. Ausgezeichnet. But we are like 4 minutes early.
So. Oh, yeah, we've got some time. We could chat here for a minute.
Yeah. The question I had was, why every time I see Tyler on screen, his head is in like the bottom 10% of the screen. He's like peeking over the edge. That's all. That's my question, but it's a little bit off topic there.
I can answer.
He's geeking out on the screen,
So-
man. He's got
Okay, so
This is written by a radioactive bug. This is.
I'm gonna do this just for you. So
Yeah.
I just moved across the entire country from Florida to Montana, and I literally haven't even built my desk chair yet. Like my office is like empty except for a computer, and like that's it. So I'm sitting in a dining room chair that I brought up from the kitchen, and I have not even adjusted my camera. Like I hooked up my camera just for this, so I'm just like I'm so far behind on everything.
Awesome.
So
We
yeah,
we should have gone with the plan to buy 550 Secret Lab chairs with the Google money, and we could have given you one, Tyler.
That was
Yeah, actually, I just muted my video because my wife literally came in and was like, "You need to build your chair." I was like, "Yeah." She's like, "You're gonna tear up that dining room chair," and I said, "I'm trying not to." I put a cushion on it because it's making me tired. Okay, that's my story.
Thanks, Tyler. Do you need to share your slides? Do you have slides for this
Yep.
talk? Okay.
Well, I have live. We're doing it live, man. No
We're
slides.
doing it live?
Yeah, hopefully I did the right sacrifice to the live demo gods. And, you never can't tell. You got to sacrifice chicken and rum to make stuff work. So hopefully I did that correctly.
Okay, you guys can hear me now, right?
Yes.
Yeah, I've got you.
Awesome. I was muted.
It looks like you also have a chair, which we will now ask everybody what their chair situation is the rest of today.
Oh yeah, this is my wife loves me. She knows I work hard and diligently down in my office, so she got me a really nice, comfortable chair.
Nice. All right, I'm gonna let you take it away and get started. Let me know if you need anything.
All right.
Okay, Mike, you want to bring up the GitHub repository?
Yep. Hang on. Let me actually. I'm going to try to figure out how to share screen. Oh, it's a big button that says share screen. Okay, got it.
Yeah, that's that one.
Funny enough. All right.
Actually, why don't we start off with some introductions? Mike, you want to go first?
Sure. So I'm Michael Smith. I do DDoS, so distributed denial of service. That's my primary day job as a field CTO type. So I'm doing lots of threat research, lots of analysis on how you can actually defend against DDoS attacks, anything that's new and breaking, such as Tunnel Apocalypse, which is a big deal this year. But basically, tons of research, tons of writing, tons of different things that are public facing.
That's awesome. Thank you. So my name's Sam Schneider. I've been doing IT and IT security operations, DevSec, for roughly 30 years. I've been in it. My first system was an Apple IIe that I was working with at my school system. So learned to program BASIC there. And Michael will tell you, he says, yeah, you're not such a great programmer, but but that's okay. And I'm a vibe coding enthusiast with a lot of different things, right? So that goes a long way. At the end of the day, my preferred methods are shell script. And I use shell and Python a lot in the things that I do, and that's really where I prefer. That's where my comfort level is. Now, as far as my background, my capability, I'm really more of a generalist, right? Think of duck, right? I'm not a dog. I'm not stuck to land. I'm not a fish. I'm not stuck to water. I'm not a bird. I don't stick to the air. I'm a duck. I can fly. I can run on land, and I can swim. So I'll kind of do all those things, right? Master of many, king of none is what they call us. I'm pretty much, I teach myself a lot of stuff. Mike and I mess around in labs a lot, and you're going to see the lab that we created for this. And just a heads up, I know the title is DDoS, and we can certainly talk about expansion into DDoS roles, but the lab itself is really a denial of service lab, is really what it is that was created.
Yeah, it's hard. It's hard to replicate the internet inside VMs.
Yeah, very, very much so. So we took the step to move in that direction. I am currently looking for a role. So I was a principal SE, solution engineer, solution architect. I've been doing this a long time. Like I said, have a lot of widgets in my head. And if you want to have a conversation, I'm always open.
Cool. So we started out and this whole workshop is iteration 1. We started out and said, okay, how are we going to do a DDoS? What kind of things can people get value out of? And what are things that we can demo so people can have their own lab? Okay. There's always a limitation because, like I said before, you can't replicate the internet. But what could we do with VMs? And so one of the things that we settled on is a little bit of a layout here. So I threw this into chat. I'll throw it again, which is just a GitHub repo. And we've got a bunch of resources in here, but there are a couple things that we will use today. There is the environment and you can set it up yourself, but in going through and building environments, it takes 90 minutes. If the workshop itself is 90 minutes, we won't be able to get through building this before we're done. Okay. So we're going to cheat a little bit. And here in the repo, I've got PCAP samples, and I have a bunch of commands that are documented down here inside of the README for this. Okay. Anything to add there, Sam?
Yeah, absolutely. So there are a couple of things. If you're running Linux, it's going to be very fast, obviously, right? It's a heck of a lot faster than Windows doing the executable for the labs. A lot of that reasoning is behind how Windows manages writes and reads, right, in its own environment. And we're outputting a lot of data to a log file. So Linux is going to be much faster. If you have a preference or if you have a capability to run it in a Linux system, virtual system, a Linux system, do that. It'll be much faster for you. But also there's some cleanup. There are some possible issues with the Windows batch file. We'll look at that. We kind of discovered that later as we were optimizing and doing our testing. And like Mike mentioned, that can take quite a while. It can take an hour and a half itself to run the lab installation on Windows. So cut that by an 8-hour day, and you run out of time real fast, right?
Yep. So there are 2 setup files here. So once you clone this, if you want to start building, go ahead. If you're on Linux, there's setup.sh. Literally, you clone the repo. I'm not in the right spot here. Let's see. You clone the repo, and here inside of that repo, you've got setup.sh. If we just cat setup.sh, you'll see that's a bash script. And really what it does is it calls, it grabs some information and logs it. It checks if VirtualBox is installed. It checks if Vagrant is installed. So we actually set up the machines with Vagrant. It installs the VirtualBox guest plugins, updates that. Then it builds one virtual machine for a DDoS attacker. It sets up a virtual machine that is the DDoS target. It goes up here. We actually add some files. So we add a set of attack scripts, and I'll show you what those look like. And it adds the PCAP samples that are here inside of PCAP samples, funny enough, loads that into the target VM under home Vagrant PCAP samples. It uploads web content, and by web content, I mean it's a single web page that says hello from Mike and Sam, but it loads that up into var www HTML on the DDoS target. We upload a couple scripts into home Vagrant bin. So these are monitoring and analysis scripts for you. This part's commented out, but part of the post install for the DDoS target is that it limits its bandwidth, which is just one of those things. If you're on a network and you've got an attacker and a target, you have to limit the bandwidth of the target so that you can actually cause an outage. So this part, I used to do it with VM or with VirtualBox. It didn't work that well. So I went and dumbed it down and did it inside of the DDoS target with the script. The script here is inside of virtual machines, DDoS target scripts, and throttle bandwidth.sh here. This actually calls traffic shaping or traffic control on Linux to dumb the Ethernet interface down to 2 megabits per second. Okay. So that's actually executed. If you look inside the virtual machines here, all of the magic really is in the Vagrant file, which is just a build file. It's like what to install, what version, how many interfaces you want to give it. And then provision.sh, which is just a bash script that when the virtual machine is created, what does it do? What does it stand up? Okay. So
Yeah, nice little interesting story there. I introduced Mike to Vagrant for this project. So he had never heard of it, but it's very, very cool. If you've never used it, I encourage you to look at it because it gives you a lot of flexibility, especially in creating virtual environments or labs, and it's highly customizable.
Cool. You want to walk us through the network diagram and what this thing looks like?
Yeah, absolutely. So basically, we've got two machines, and I'm gonna have to bring up my own diagram because I'm struggling to see that one there. So let me bring
Really?
it
Oh,
up.
I can fix that.
It's kind of small on my screen. I'm not sure what you're seeing there.
Maybe.
But basically, what we've created, we're using Oracle VirtualBox on the back end. So that's what Vagrant uses natively to create the virtual machines, right? That includes the virtual switch environment on here. And we've created the two machines that Mike mentioned, right? The DDoS attacker, and the target machine themselves. We wanted to have something to kind of move in between, and there's also an additional interface here on the attacker box, which allows us to go in if you want to establish. So if you've used Vagrant before, then you'll know this. It'll be repetitive information. If not, you can actually go into the directory of the virtual machine where you've actually unzipped it or unpacked it, and you can type Vagrant SSH, and that will automatically use the keys that were generated during the install and will drop you into a console session. So that'll drag you into that. Alternately, if you're like on a Windows host and you have something like PuTTY, for example, you can set up, we've actually done port forwarding to an external address. So there is port forwarding, as you can see on the attacker, for 22,200, and relatively on the target 22,001. And all you have to do is do a loopback. So you basically SSH through PuTTY to the local host for 127.0.0.1 using those port numbers, and it will actually port forward back into the Vagrant VM and drop you into a shell. So alternately, also on the target, there is a 8080 port forward as well. Unless you took that out, Mike. I don't see it listed in the diagram.
No, I just didn't list it in the diagram.
Okay, there's a port 8080 as well, so you can actually, go to and check out the website itself. There you go. There, Mike just went through it. This is all in a type of light formatted, distributable type of image that's pulled down onto the host OS, kind of similar to Docker in a way, right? The host OS is really providing the back end, but this is a light version of the operating system that's being installed and managed from the image. So that allows you to do full capabilities and actually observe what's going on in your environment. This is how the environment's set up. It's pretty cool, and can't wait to get in some demos for you and show you how we can actually use this.
Yep. Let me throw some resources at folks. So here's VirtualBox. Okay, so you'll need that to make this build. There is Cool. And then Wireshark, which I already mentioned, but I will add it to the list here. Okay. Wireshark is a good thing to download now because in this directory that's here, PCAP samples, if we go into PCAP samples, you've got normal traffic. So that's just regular traffic that's going. You've got a ping flood for about 15 seconds. It might be 10 seconds. Don't quote me on it. You've got Siege, which is a HTTP GET flood. And you have Slowloris, which technically isn't a DDoS, but it is a unclosed session. It's a server. What is it? It basically takes up all this. It takes up all the server processes. Yeah, it's like a keep alive or a half open connection or an unclosed connection, unterminated connection. Okay.
Loads that memory up.
What's that?
Loads that memory up.
Yep, fills up your memory or fills up the pool of server daemons. Okay. Let's see. In order to get into our VM, so once you've got stuff built, you have a couple options, right? Probably the easiest here is inside of virtual machines. I've got a directory for DDoS attacker, and then there's another one for DDoS target. So it's /virtual machines /DDoS target /virtual machines /DDoS attacker. And Vagrant has this cool thing where it actually does the key exchange. So you can just do Vagrant SSH, give it a couple seconds, and it will actually log you into that particular machine. If you do an ls here, you'll see there's a bin directory. If we cd into bin, we do an ls, and then we have attack scripts that are here. So we've got anything that starts with DDoS is a DDoS attack. Anything that starts with monitor is a monitor script. So it'll tell you what the availability is of the target. And then there's this guy right here, which is traffic normal simulated. And what that does is, I'll just cat it. This is actually ran in the background, and it's run from cron every minute. So what it does is it basically picks a random time between 1 and 60 seconds, waits, so that way it adds some randomness. It grabs a random user agent. It gets a random number of requests that it wants to make. It grabs a random source IP address, and it runs through curl with that user agent to load some traffic. Okay, I'll show you what that looks like on the downstream side. One thing that we forgot to mention is that here on the DDoS attacker, it has a metric ton of internet interfaces. So it's one Ethernet. It has many aliases, all with different IP addresses there, all the way from 3, which is the main IP address, up to .254. Okay, so if you do IPA here, you'll see it just scrolls on forever and ever and ever. And somewhere up here at the top is 3. We don't need to go there. Okay, that's the attacker. So I'm going to go to, and one of the problems that I had with this is keeping track of which machine is which. So I've got 5 terminals open. This is in my host. This one is in the attacker. This one, you'll see DDoS attacker. So Vagrant SSH. That'll get me into the attacker. This one is in the DDoS target. Vagrant SSH. And here, Vagrant SSH. This one's in the target too. So I keep these separated mentally. So I've got attacker, attacker, target, target. Okay. Now, inside of the target, I have some tools too, right? So if I cd to bin, ls there, I've got a monitor script that just makes a single curl request and spits out the contents of the website. So if we just do /monitor curl, it should. There you go. So I get that little simple HTTP page or HTML page. Throttle bandwidth, I showed you before, that cuts our bandwidth, and we have a couple analyzed there. So if you give it a PCAP, it'll show you the top talkers, top ports, et cetera, et cetera, et cetera. And I didn't update myself. I added a couple things here. I added a couple scripts, but we have some monitors that are there. Okay. And I did these last night. So let me check and make sure that I added them correctly. I might need to commit them.
By the way, while he's doing that, does anyone need any assistance or guidance with regard how to, download the project repos or how to clone them on GitHub? If you do, just let us know. We're happy to help you with that as well.
Yeah, just throw it into chat. Okay, cool. Awesome. So I've got 2 monitors here. I didn't actually upload them. I'll go do that behind the scenes here in a second. But I've got iptraf, which is a command that shows you the traffic that's coming through the Ethernet interfaces, and then endload, which does it the same. They are air quotes graphical. Okay, so if we do sudo iptraf, okay, and so we can hit IP traffic monitor. ETH1 is our internet interface. So you can see what's coming in, and you'll see, oh yeah, there's some UDP coming in. At some point, we'll see HTTP come across. We can also go into another shell, and we have, I didn't add it yet, but we can just go look at our Apache logs. So we just do sudo tail-f var log apache2 access. Okay, and so what that does is it just streams the requests that come across to Apache, which is the web server that's running. So anytime there's a request that comes across, you'll see this stream. You'll see what they are in real time. I think I just lost to Sam. Hey, Stoner, can you look for a Sam and re-add him, please? So that's going to chug along and do its thing, right? And you should see stuff scroll here eventually when the script comes and runs. Okay. Right. So here we go with iptraf. In order to get out of iptraf, you can queue. You can go down. The one that I used a lot is detailed interface statistics for ETH1. So you can see as the packets come in. And so you'll see, here we go. We're starting to get some. So we've got some IPv4 coming in. We've got the occasional UDP coming in. There we go. Right. So that's just a statistics for your interface, and it'll give you a bunch of different breakdowns and things. I just like the detailed interface statistics because it shows abuse as it's coming in, right? And we'll see it here in a second. And so that's sudo iptraf. I'll throw that into chat for you all. Okay. There's another one that's here. There you are. Which is endload ETH1. So endload gives you the same thing. It gives you a air quotes graphical interface. So what you see here is we're monitoring ETH1. This is incoming traffic, and you'll see it's like nothing, right? And so far, we'll peg it. And then outgoing here, you've got like 0 outgoing, right? So pretty quiet Ethernet interface. Okay, we ready to go throw some traffic?
Throw some shade on it.
Throw some traffic. Okay, there's one other thing that you can look at, which is, let's go do an attack first. Okay, so we're here in bin. Oh, yeah, Mike needs to remember how to type. So I'm just going to do a DDoS ping flood 2 minutes. So let's read it first. Okay, so what the script does is that gets a random source IP address, which is actually down here. It runs a loop up to 100 processes. For each one, it starts an attacker, and then it calls a command called fping. So fping is fast ping. All right. And there's a bunch of things that we're using 1470 bits per packet or bytes per packet. We're giving it a source, which is a random IP address that's also on that machine from all these interfaces. Here is the target, which is 192.168.56.2. And all we're doing here with the ampersand is we're just forking it. So it's similar to a fork bomb. We're just basically saying run 100 processes. All of those processes are launching a ping. Okay, with a big packet, by the way. So I'm just going to go here, run that thing, bam. And you'll see it's pinging away. We go into our target here. You can see our bandwidth is ramping up incredibly fast. Okay. We're not getting any web.
Where it becomes an incapacitated or sluggish.
Yeah. So we go into our target here. And if we do monitor Siege, what Siege does is it sends HTTP requests over 10 seconds and then looks at what the latency is. Okay, so you'll see it takes a second here. Now it's sending, and I know it's in blue, so sorry about that. But it'll send 10 seconds worth of traffic. Okay, and what you'll see here is our transaction rate is we're getting through, but we can only do 2 HTTP requests per second. Okay, there's my flood. Let's go back to my monitor here. You'll see I'm getting, 106. Looks like the attack is starting to go down here. The numbers are getting smaller.
And by the way, it takes some time for your systems to recover from this type of attack. It doesn't happen instantaneously. It slowly has to clear out the connection requests and attempts, close those out. And it takes a little bit of time. So it's not instantaneous, even once you mitigate it.
Yeah, you'll see the numbers. Numbers are still up high. They look like they're coming down now. Yeah, one of the things that I found with this is even after all the traffic, the attack traffic is done, that the network is still saturated and it's still sending packets. And especially from our target is we're still getting responses back. Okay. And so, yeah, it takes a little while for just the network to quiet down, for the attacker and the target to quiet down just their operating system, because they queue up all the responses, only the network interface is busy. And so that queue, it has to work off that queue. Now, if you send too many packets, and it is possible to do that, if you send too many packets, then at some point that queue fills up and the targets just starts dropping, but the queue is still full and it's still there and it's still waiting to send those packets back. Okay. Let's see. The next thing that we need to do is a packet capture. So here I am, and I'm going to quit out of that. I'll show you the stats in IPTraf. Show you what that looks like. So if I go to detailed interface statistics for ETH1, you'll see I like this one better because the numbers scroll fast. But you can actually see here's all the attack traffic coming in. It's on IPv4, and you can see that interface is crazy ICMP. Okay.
Yeah.
So that should tell you something, which is when you get a ping flood, your normal traffic doesn't have a lot of ICMP in it. right? Like this is not like you might see like normal ping on a Linux environment is 1 ping every second. Okay. I'm sending thousands and thousands every second. And so you'll see that the ICMP fills up. I think my attack is over. My numbers aren't scrolling anymore. So, yep. So my attack is over. Okay. And you can see what the total damage is there in all that ICMP traffic. Okay. So normal traffic, if we queue out of that, go back into it, you'll see normal traffic as it comes in. Yeah, this is a slow website, but you'll see a lot of it is IPv4, a little bit of UDP, that's broadcast traffic. You'll get the occasional ICMP that comes across, but most of your traffic is going to be IPv4 or IPv6 because it's all TCP. It's all TCP traffic. Okay. Now, we've launched this attack. Let's go learn one more trick, which is if we exit out of this, and we can use TCP dump, which there are lots of different variations of TCP dump. If you use TCP dump.I ETH1, and I have to sudo it, there are lots of different ways to capture packets, right? You can capture it off a switch with a port mirror. You can capture it off a firewall. You can capture off an IDS. Inside of Linux, you have TCP dump, which grabs it from the interface, and I'll run it, and it looks like that. Okay, so, pretty quiet. I can go here, and I can do monitor siege. Okay, and come back here to my TCP dump. You'll see some stuff scroll, right? And you'll see some HTTP in here, some HTTP coming across. Here's broadcast DNS here, or where is it at? Something big. I have to take a look at that. Oh, so this is multicast DNS, which is why the lines are so big. And then I'm back to kind of normal, quiet. You'll see the occasional HTTP come through. Okay. And so that's TCP dump. But TCP dump also allows you to capture to a file. So you can do -w, normal.pcap.
I hope all this makes sense because, I is obviously intuitively interface, right? W, intuitively write.
Write to a file, right? And so that will write. You won't see it. In order to stop the capture, you just Control-C it. And then I put it up. There is normal.pcap. So I can do file normal.pcap. Okay, so that's a pcap file, and you can read it. TCP dump -r, which is read a file, normal.pcap, boom, and it spits it back to you. Okay, so if you look here inside of the GitHub repo, you have pcap samples. Okay, pcap samples, you've got normal traffic, which is a little bit longer sample, right? This is a really short sample, so there are only a couple packets. But that's a normal sample for a length of time. I think I did it for 2 minutes, but you've got the ping flood, which is what we did, and we'll go capture that. And then you've got some other stuff, and we'll get into that. Okay. In the lab itself, you have a X Windows that's running on the target. Oh, wow, that resized itself crazy small. All right, you behave. There we go. And you can log into that. You can log into any of these machines. The password is DDoS, all small letters. Okay, so you can log in here. Yes, system restart. Here, under apps, you have Wireshark. And you can just go in and say file, open, normal traffic, open, and there is your capture inside of Wireshark. Or you can do the cheater. And if you have Wireshark inside of your host operating system, I can go here and do File, Open. So here I am into the workshop under PCAP samples, and there is normal traffic, and you can open it up. Okay, unfortunately it's small. I don't know if I can make it bigger. I don't know if I can make it bigger, but that's okay. All right. But for those of you playing along at home, you can go in and load this up.
Awesome.
Okay. Cool. All right. Now, let me do a quick pulse check. We're 30 minutes in. How's everybody doing with this?
Thumbs up in the comments if you're still hanging in there.
Good check. Okay. All right. Cool. Good deal, folks. Awesome. I think chat is delayed a little bit. That's okay. All right. Because everything comes in at once. Awesomeness. Now, let me get back on agenda here. Okay, so let's go capture a ping flood. Okay, so here I am, and I'm going to start my ping flood. So there's my ping flood for 2 minutes. And I'm going to go here. So I got that staged. I'm going to go in here into my target machine, and I'm going to do my sudo TCP dump, but I'm going to run a command called timeout. And I'm going to do this for 10 seconds. And so what timeout does is it's basically a Linux command. It says run this command for, in this case, 10 seconds. And instead of me having to manually Control-C it to quit the TCP dump, it'll just send the hang up command to TCP dump itself. I do want to change this to pingflood.pcap. And so I'm going to start my attack. Ping flood's on its way. Go capture some files. Takes a second, which is one of the things of the DDoS world, which is things happen fast and slow at the same time. It happens fast and slow at the same time, right? So the traffic comes across fast, but sampling traffic, looking at traffic, all of that, it takes a little bit of time. Okay. Which is why people a lot of times will use automated systems that sample traffic, analyze what the top talkers, top ports, all of that, look down deeper inside of the packets, and then institute a block of some kind.
Yeah, we'll look at the TTP mitigation here towards the end, but also when we go through and look at the actual PCAPs for the flood and the HTTP attack, then we'll definitely talk about the mitigations of that as well there.
Awesome. So I made all of my I got my sample here. My attack is still ongoing, which is okay. But let's go take a look at this. So we can do a sudo TCP dump -r. So read pingflood.pcap. And you'll see as it scrolls up, right? This is an ICMP echo reply, ICMP echo request, and you'll see the sources for the echo request is like 6856. 216, 97, 210, basically all of these just random sources that are sending ICMP echo requests to us. That's a ping flood. Okay.
Yeah, let's talk about what happens out in the wild, though, as well. So with
Yeah.
these types of attacks, especially like a ping flood, um, most of the time the source is going to be a spoofed IP because they're trying to avoid detection, right? And they will actually spin up zombie farms or bot farms, and they'll utilize that. They could use rotating IP schemes on the back end. This is all to avoid detection, but it's all using our friend ICMP type 8 types of packets that are coming in. So this is something that you can certainly perform a Wireshark filter on, which we'll get into.
Yep. So now, catch us up here. Wireshark. So Wireshark has some tools that can help you. Comes with a warning, though. Comes with a couple warnings. Number one is that if you have a packet capture that's too big, which happens a lot inside the DDoS world, right? You can capture, if you capture traffic for too long, you make too big of a file, Wireshark tries to commit all that to memory, and you can crash your operating system. You basically, or you'll crash Wireshark. Another one is people can send crafted packets. There are a couple tools that do this that are specifically designed to crash Wireshark. Okay, and so you can do tricks to pre-filter, and there's some other things you can do to minimize the size of your capture so that Wireshark can actually read it. And there's one more, which is Wireshark itself is designed to capture packets on an Ethernet interface, which means that a lot of times it needs administrative rights in order to be able to capture on an interface, which also means that if you're running Wireshark as an administrator, people can craft packets that actually exploit Wireshark to take over your operating system. So, see me your downsides, it's still fun. Okay. One of the ways that you can capture less traffic is if you go here to our capture here, you can capture something like I did here, like 10 seconds, 5 seconds, capture a smaller sample of traffic to make it smaller. You can also add filters inside of TCP dump to say, hey, I'm only grabbing UDP traffic. I'm only grabbing ICMP traffic. You can feed filters to TCP dump in order to make that capture smaller. The last thing that you can do is you can use tools to analyze packet capture without needing to load stuff into Wireshark. But we'll get there. I have some tools. It's just, if you look at the output here, when you read a file, all of this output that you see here is ASCII text, which means you can use all of the regular Linux command line stuff in order to be able to read it. Okay. But Sam, you want to talk me through Wireshark with the ping flood?
Yeah, absolutely. So if you suspect something's going on in your neighborhood, you start looking for high traffic volumes that are occurring on your network. In the case of a ping flood, we're going to do two. We're going to do an ICMP ping flood, and we're going to do an HTTP GET flood. So we're doing both of those in the PCAP analysis. If we wanted to look specifically at that, first let's identify what the difference is. Okay, the ICMP ping flood basically overwhelms the target with ICMP echo requests. That's all it is, right? It's just consuming bandwidth and CPU, and then utilizing a traffic like TCP dump or Wireshark on the back end to actually collect a PCAP. We can actually start looking and analyzing this traffic. And what we're looking for is a high volume ICMP echo request packet or a type 8 packet to the impacted host. In this case, that would be our target, our DDoS target. What they're looking to do is basically just deny service to the resource, right? I mean, that's a given on the endpoint. Like I mentioned earlier, they're typically coming from multiple sources or spoofed IPs. So it makes it a little harder to detect on this. So if we go into Wireshark and we have our interface or our PCAP set up, we can actually set up a display filter, and it's going to be a display filter for ICMP. and it's comma type is equal to
It's a
equal
dot. It's a dot.
okay, dot. Yeah, right.
comma.
Okay. Equal 8. So that's actually telling it type 8. But ICMP is going to be enough in this case because we know what we captured, right? And this is going to show us source and destination. Now we have something that we can consider, right, from a mitigation perspective. And exactly once you go in there and look at that, you can also do identification or analysis on the payload size. The larger the payload, the more impact it's expected to have on the host. So between that and looking at the time to live and the IP values that we're sitting in here, we can identify the source. We can identify potential impacts. Okay, and once we do that, let's talk about how we can consider mitigating these types of attacks. Specifically, rate limiting is your best friend. That is your best friend when it comes to these type of attacks. That in geo IP filtering. So this is something that I do natively, automatically. I use geo filtering lists out there because especially when it comes to nation states, of course, you could also make the argument that, okay, well, they could VPN, VPN somewhere, or they could do a VPN tunnel somewhere, and they can actually perpetrate the attack from a local source that's not within the geo. And yeah, that's a fair argument, right? Rate limiting, though, by user or by IP or by source is going to be the best way to do that. So it breaks down to monitoring and identifying, right? GeoList would be a good, easy first start, and then rate limiting to block the ICMP at your perimeter firewalls. But perimeter firewalls themselves are not the answer. So you need some level of intelligence about what it's doing, because you don't want to block legitimate traffic in these cases. So you seeing all the I can't see your screen, Mike, sorry.
It's tiny. I know. Hopefully everybody's following along at home.
Can't see what's highlighted here.
This is a thing. This is a comment I wanted to make, right? So normally up here you have here's the echo request, right? So this is right here. So there's type 8. And then there's this big, huge chunk here, which is data, which is truncated for the display, but it's here. It goes on forever and ever and ever. And in the attack script itself, DDoS ping flood 2 minutes. One of the things that I did here is a -B 1470. So that says making the packets themselves 1470 bytes in size, and all that the fping does is I lost my pop out. Anyway, I'll get there. What fping does is it adds a bunch of zeros to the packet to get it to 1470. Quick question for everybody. Can anybody tell me why I set the packet size at 1470 and not, say, 2000 or 2500? That's a question for chat. I know it's delayed. Okay. I'll give you a hint here. Right. I don't have it here. There's a thing that networks do, and it is internet routing. Yes, it's Richard Wallace, but he's the plant. He's the ringer here in this conversation, and it is because there's a thing called an MTU,
1500,
which is 1500. So if a packet is bigger than 1500 bytes, the routers and the operating system and the routers on the way, they'll actually fragment it into different packets. And so I kept it at 1470 so that it was smaller than the MTU, so I could get the whole packet delivered.
Makes it
because
bad.
a lot of routers will actually discard it if it's above that. So I wanted a lot of traffic, but not so much that it gets discarded on the way to the target. Okay, cool. I think we've beaten ping floods to death, Sam.
Yeah,
What do you think?
we did, didn't we?
What do you think? Yeah, I think we're okay there. Next attack, which is Get Flood. You want to talk us through Get Floods?
Yeah, absolutely. So on the Get floods themselves, what it's really doing, it's just sending a massive number of HTTP or HTTPS GET requests to a target. And it's just basically over consuming and over subscribing resources at the end of the day. What it's looking for and what you're looking for when you actually go through a PCAP is you're looking for specific endpoints, web servers or web farms. You're looking for specific files like login or index.html, things that are generally known to be attached to a website. And the varying TTP on this, they appear to be legitimate a lot of times in the header information, so it's kind of hard to determine. You see the volumetric attacks that are occurring across, and they typically happen across botnets when you're seeing this. And the issue is especially with this type of attack, is this may bypass basic firewalls because it's simply looking at protocol compliance requirements as far as firewall rules. So yeah, is it coming in port 80, 8080, 8081? Is it coming in 443? We'll get that. Did you already do a capture, or did you want to look at a capture?
Let's go look at normal traffic.
Okay.
And then take a look at the attack, right? Yeah. So here I gave you the script, so I just read it, and I need a terminating line on it so it wraps around, but that's okay. So what this does is it's just a shell script. It runs Siege. So Siege is it's a HTTP load tester, right? So it makes a lot of requests, and I've been using Siege for a long time. You can use it like a lot of DDoS tools that are out there. You can use it to put a load on your web server, okay? Make a lot of requests to see how the web server responds and see what choke points you have, and run analysis to figure out, like, how do you make your web server and your web application faster. But you can also turn around and use it to send a bunch of requests. Same thing, right? And so in this case, what we're doing is we're running Siege. We're saying, oh, I lied right here. I said we do 50. We're actually doing 300, which gets throttled down to 250 concurrent users. So we're simulating 300 users going to the website at the same time. We are launching the attack for 120 seconds or 2 minutes. And our target URL is right here. And so it's the target with a query string of y equals because we hate you. A lot of times inside of web application DDoS, you will see outliers of some kind like that, where they send a message to you to let you know that they hate you. So Loic used to do that. Other tools I've seen will do that. Or what happens sometimes is they add a random string, and you'll see this inside of Slolaris, excuse me. They add a random query string there to evade any kind of proxy or caching that you have upstream of the web server itself, right? So basically, if you add randomness to the end of the URL, it's a unique request, and it will break through that proxy that's there. Okay. Let's look at normal traffic. So let's go back to Wireshark here, and you can use the samples. So let's do normal traffic. Oops, I'm going to remove my filter. That helps. And what you'll see here, I could do like TCP port equals 80. I've got an extra chunk on there. Okay, so that's just, let me Control C that, drop that into chat. Okay, so TCP port equals 80, hit return, and that'll give us all of our traffic. And you can actually click on this and say, follow TCP string, and you'll actually see what the request looks like. So it's get / HTTP 1.1, and you have a user agent, which is normal. This is, I believe, Chrome on Windows 10, right? And Windows 64-bit Windows 10. And you get a response just like this from the web server. And then here's our regular HTML page. Okay, that's normal traffic. You can see a bunch of these that are here. And when you click right click, follow TCP stream, you get basically for that TCP session, there's your SYN ACK, here's a get /, here's a get /, and then here is tear down the here down is tear down the session. Okay, so the client connects, TCP sends a couple, right? So usually when you go to a website, you're loading anywhere from 1 to 40 different requests or objects off of the website, and then closing out the TCP section. That's normal. That is absolutely normal. Okay, kill my filters, add my filter again. Add it. Okay. And you'll see there's a ton of these, right? Build it up, get HTTP, get HTTP, get HTTP, all from different IP addresses that are out there. Okay. And you'll see as we go through different source IPs, that's normal. That is absolutely normal web traffic. Okay. If we load up a siege for 10 seconds, okay, looks similar, right? Only you have a lot more of it. So you'll see here's our HTTP. We go right click, follow HTTP stream, right? And you'll see actually here, why is because we hate you. And the user agent here gives us a tip off that it's siege. So there are a couple things that we can actually look for and filter out in our traffic if we have a device that allows us to do that. Okay. But let's go make some attacks and see what it looks like. Okay. So here we are on the attacker. I have DDoS siege. 2 minutes. That's queued up. Over here, I still have that. I'll Control C it. Right? That's a tail-f verilog Apache 2 access log. And did I add that to the repo? Let me see. I might have a cheat sheet for you, or a cheater for you here. Virtual machines, DDoS attacker, attacks. Whoop, nope. I'm all messed up. DDoS target scripts. There we go. And I don't have the monitor there. I'll put it up. I just have a script that calls this. I don't need it, but I'm trying to make it easy for everybody else, okay? But we just look at our Apache log. There it is. We're ready to launch this thing. Bam. Running siege. It takes a second. Okay, max number of users is capped at 255. So the count of 300, it ignores that, but that's okay. You can do that in the file. And here we are. Here's all of our requests coming in, and you see it all scroll through. It scrolls incredibly fast. It's just a wall of junk. And that is all of our attack traffic that's coming in. If we go here and we go to IPtraf, detailed interface statistics, ETH1, you can see all that coming in incredibly fast. And you'll see it's all TCP traffic, right? Of course. is TCP traffic. Okay. Anything else I want to add to this, Sam?
Well, I mean, once you identify what it is, TCP traffic, then you want to identify, what the port is, what the destination host or IP is, right? You want to walk through that basic checklist at the end of the day. And Mike, something you mentioned a couple of times, and I'll reiterate, over and over again, TCP follow stream is your friend. That is definitely your friend in this case. And when you want to look at what the agent information is with the specific packets that you're filtering against, that's incredibly important to identifying this attack, because what I said earlier, perimeter firewalls will typically allow that traffic through because it meets the rule, right? Now, next-gen firewalls, whole different level. So next-gen firewalls actually have application controls and evaluation controls, and you can actually look at rate limiting and things of that nature, which will allow you to at least somewhat mitigate it. There's always going to be workarounds with that, though.
Yep. So this attack is coming to an end. One thing, yep, there it is, right? So you notice it starts to just trickle. That attack should be over. And there we go. Now, what was my availability? My availability was 100%. But I sent 2,000 HTTP requests per second. So we did pretty well. Okay. One thing that's interesting to me, and this is always a problem in DDoS mitigation, which is if you look at the URL I'm going to, that URL is HTTP, right? If we're able to take, and most websites now are going to HTTPS or TLS, and so that traffic is encrypted. It makes it a lot harder when you're inside of the network upstream of the target. It makes it a lot harder to actually look at what's inside of that request, right? You basically, if you go back here to Wireshark, what you see is starting a TCP session, encrypted stuff, end of TCP session, right? You can't actually see that HTTP as it goes across the network. And so it makes it a lot harder to go in and identify what's inside of that application layer attack. Okay. Cool.
Yeah. Very cool. Very
awesome.
Cool.
Now, I have some tools here. Let's go back here to our target machine, and I'm going to quit out of IPTraf. And I have some tools. I have some tools here to understand some of this traffic. If we go, let me show you here. Okay. These are here. So I've got analyze the HTTP logs. That's really simple. That's just the sudo tail-f var log Apache 2 access log. That's what I have scrolling right here. It's just in a nice, make it easy so you don't have to remember the command. I've got analyze top destination ports, which is going to be ugly. It's going to be ugly. It's a trust me bro on this one. What it does is I check to make sure that you list a file. Then I check if the file exists. And then what I do is I run this big ugly command line. And what it is I'm saying use TCP dump to read the file. Use don't resolve host names. Okay, so don't do DNS resolves. Read a file which is argument 1, which is on the command line, what file you want it to read. Pipe it through awk, which says grab the 5th column. Then run it through cut and grab the 5th field and then grab the 1st field out of that. So I'm just going and slicing and dicing that that TCP dump output and grabbing the piece that I want and then sorting it. So put them all in order. In this point, this is top destination port. So I'm grabbing a list of ports. I'm putting them in order. I'm counting them and making them unique. So I'm just giving you a table of how many ports were targeted. And then give me the top 20. Okay. What does that actually look like? All right. So here I am in PCAP samples, and I want to do analyze. Really? ~bin/analyze top ports sh. I might have to bash it. That's why. // siege. I had this problem before. What did I do? All right. My path is all weird, guys. So hey, bear with me for a second here. We'll make this work. Ports. sh /pcap samples normal. Try like normal traffic. I don't want to do it. Anyway, we're going to cheat. My scripts are broken. I'll fix them. We're just going to do this. We do this cd /pcap. I'm just going to dump this here and /normal. All right, I'm getting there. It's because I'm running TCP dump. It takes a little bit of love. All right, I'm going to embrace cowardice and give up on that one. We're going to do this the GUIX way, which is here we are, file, open, normal traffic. Okay, here's my normal traffic, kill my filter. And Wireshark does this for you. We go up here to statistics, IPv4 statistics.
Thank you. The beauty of Wireshark.
Destinations and ports. Okay. It's tiny though, and I get that. But you can actually see here is by count. Okay, so you can see here, here's 192.168.56.2, which is the target, TCP, which is the protocol, port 80, and we have 816 packets that went there. 224, which is multicast traffic or broadcast traffic. Then we have 78, which is reply traffic. Here's some more reply traffic. Right, and you've got all of these different 56, whatever. So Wireshark will actually give you stats. So this is the ports, destinations, and protocols. You can go statistics, IPv4, IP protocol types, right? So we've got a lot of TCP, some UDP. We've got statistics, IPv4, source and destination addresses. So this will give you your top talkers. Of course, your Ethernet is usually your top, your the Ethernet port that you sampled off of has the most traffic because you're catching all your replies. But ignore that and look at the other ones that we're sending traffic, right? Because you typically, when you look at packets or you analyze a DDoS, what you're looking for is who are the top talkers, what are the top destination ports, if it's port 80 or 443, what does the HTTP request look like, how can we block that, how can we do a lot of things, okay? And then there was one more here, which was source TTLs. No, that's all the statistics we want out of it. Okay, cool. Now, this is normal traffic. If I go and I do file, open, and here I have Siege, 10 seconds. Open. Ta-da. And now I can do statistics, IPv4, do like destinations and ports. Okay, you'll see all sorts of craziness that shows up here. Come here, make yourself small. Okay, somewhere in here, I'm gonna sort it again. Let's by the top. Let's go the other way. So I've got .53 sends all of this junk, and you'll see it's just distributed out across all of these different ports. Those are all the source ports. As it comes in, it basically goes round robin through all of these different ports to send. Okay. If we go back to statistics, IPv4, IP protocol types, you'll see everything's coming in on TCP, statistics, IPv4, source and destination addresses. This will be fun. Okay, everything's coming in from .3 and it's going to .2, with the exception of this little broadcast traffic that's here. But you see all of this traffic. So we can actually go and look for, add a filter to say, oh yeah, only show me traffic coming from .3. Follow the TCP streams. What does that traffic look like? Okay. Anything else that I need to add on that?
Well, there's a couple of things that we could discuss here as well, especially when you're getting down to identifying the behavior and looking for clues about what's going on in your environment. Looking for things like incomplete handshakes, like syntax, and then reset packets and TCP retransmissions, which are going to be like, where they have a low window size, like a 0 size window. And those are typically going to show up in black anyway, so we'll see a bunch of those. But the statistics of conversations, you can see all the endpoint information, where they're coming from, and visualize that for your top talkers. So you can actually start putting together a graphic picture of what you're seeing in Wireshark. So that's incredibly important, especially when you're capturing, collecting evidence. And, I'll remind you that anytime we're having an attack, any type of attack, but especially a DDoS attack, you need to collect PCAPs. You need to be able to collect evidence of the attack, because obviously there's going to need to be a report filed, and you need to make sure that you have that evidence in an environment where you've collected it. One other thing I want to ask everyone, is everyone aware of what happened last week? There was a pretty significant event that happened last week, and if you know, just chime in on the chat. Pretty significant event, especially about the topic we're discussing. Did I give it away? Okay, well, I'll go ahead and throw it out there. So last week, Cloudflare announced that they off-put or mitigated a 11.5 terabit per second DDoS attack. It was a UDP flood attack that was being generated out there. 5.1 billion packets per second. High volume, low timing on it. It was only 35 seconds. And why is this significant? Because it was using something that I know is close to Mike's heart, because when we were at Unisys way back when, he was talking about IoT stuff back then, and that's a long time ago, talking about, toasters on the internet effectively was his catchphrase. Well, this was actually generated through vulnerabilities of IoT appliances, things like DVD players and TVs that are sitting out there, right? That are connected into Google Cloud provisioners of some type. Very, very eye-opening. And sometimes, we'll see nibbles of what's to come, right? Sometimes when an attacker is looking or doing a proof of concept or proof of value, they're going to go out there and they're going to start touching things and actually seeing, hey, is this an open area where I can exploit it, where we can actually do harm? So this is what they'll start doing. They'll start nibbling. So you'll see these short, high volumetric bursts of DDoS attacks that are sitting out there. And we'll be getting into mitigation at a certain point. Actually, here coming up pretty soon, actually, after Mike does his slow LoRa stuff. So we'll talk about mitigation on this, but in this case, one of the mitigation points, there are a couple that we could discuss. Using a WAF is a very low-hanging fruit type of technical solution or technical control that you could use to reduce the impact of a DDoS attack. Although, keep in mind that if the bandwidth's saturated coming into your WAF or into your connection, it's still going to cause disruption. It's still going to cause a problem. So looking at something like a cloud WAF, like an encapsular, Cloudflare, or AWS Shield, something of that nature, a CDN of some type, which will off-put and divert bad traffic, is also another tactic that's used. So I know I used to work for Imperva. We had on-prem WAFs, and of course, when large-scale volumetric DDoS attacks started happening, it's much easier to look at handling this outside of your firewall, right? Because your firewall is still processing it. It's going to choke that at the very minimum. So a CDN that's cloud-based is going to help immensely. Another tactic that can be used to help off-put these are CAPTCHAs. So now we know why CAPTCHAs are important, because it's going to basically discard traffic that doesn't answer the question and meet the questions in there. But
so let me jump in here for a second. Some very smart person delivered it in 2022, had a presentation at VetSecCon about DDoS mitigation and what are the different technologies and what are the pluses and minuses. Go check it out. And by smart person, I mean myself. I'm being facetious.
I thought that was you.
Yeah, that's me right there. But you can hardly see me through the captions.
I would throw some additional words onto that smart title there, buddy.
Let me. Yeah. I got that. All right. We got 15 minutes. So let me go do a slow Loris, and talk you through how that works. Okay. So slow Loris itself is an attack. Oh, I don't have it. It's an attack, and what it does is it sends incomplete HTTP requests. Okay. It's technically not a DDoS. You can distribute it, which works really well. In fact, it works great when you distribute it. But what it does is inside of Apache, you have when you stand up the server, you have the master Apache server, and then it spawns all of these different processes. Each process answers requests from users, and they answer a certain amount of requests, and then they die, and then the master process spawns a new one over the top of them. That way, if there's a memory leak inside of Apache, it won't be an issue, because that process is replaced before that memory leak will start to have an impact. Okay, so if we do etc. Apache 2 ls cd. I think it's in apache2.conf. It's either in apache2.conf or it is in modules loaded. Yeah, it's in modules enabled. cd mods enabled ls cat. It's npm, I think, event conf. Yep. Okay. So what happens is when Apache is first started, it starts up 2 servers. And this is configurable, right? It's a configurable file. It starts up 2 servers. And it's ready for 25 threads. And then it has spares, which is how many does it want to keep extra in case there's a spike in requests. Okay. And then you have a thread limit and threads per child, which is how many requests or how many threads does each running process run. And once it hits the cap, then it just times out, right? It's like, okay, I'm done. And then max workers, which is how many processes can be running. And then max connections per child, which is how many requests from browsers does each one listen to. But this was all designed so that you manage, you've got how many processes are listening to requests, how many are answering requests, how many extra you have sitting on the side in case of a spike, and then what's the cap on how many requests each process listens to before it dies and is replaced, and a cap on how many total server processes can be running in order to keep you from running out of RAM and processor on the server. Okay. And so it's just kind of pool management. But what Slowloris does is it makes requests and then it just doesn't terminate them, right? If you look at your normal, HTTP request, you've got get/HTTP 1.1, and then you've got the rest of the headers. You have 2 carriage returns that says end of headers. Then you have the body of the request, and then 2 carriage returns at the end of the body. Okay, and so Slowloris sends the request, but never terminates it, and then never terminates the TCP session, and it just leaves the server hanging. So as your server pools are out there and they're running, eventually you hit either the max request workers, right? So each worker is like, hey, I've done enough, or you hit the max number of servers, or the machine runs out of memory and then the server dies. Okay. So that's what Slowloris does. Now, the important thing is that sometimes if you're throwing a lot of network traffic or an HTTP GET flood, you can also run Slowloris in combination with it. And there are other tools that are out there. There's Rudy, there's Slow HTTP Post, there's a couple others. They all work roughly the same way, which is unending connections. And so the blue teamers are worried about the volume and dealing with the volume, but then it's this sneaky thing that actually causes the outage on top of it. Okay. So what does that actually look like? Let's go back here to my attacker, clear things up. Let's do DDoS, Slowloris, 2 minutes. Okay, let's read it here. Right, so all it does is it says, I set timeout so I can limit it to 2 minutes. They say, okay, here's Slowloris on port 80, use random user agents, and here's your target. And then we will go ahead and run that. Plunk. What? Timeout? Really? Fine. I'll do it my way. Oh, you know why? Because I'm a dumbass. Okay. Technical term. It's not. I added an E. Sorry. It's a typo. All right. All right. So I'm just going to paste that down there. Bam. So here we go. And we are creating 150 sockets connecting in. You'll actually see traffic come across. We can go here. We can do monitor curl single. We're connecting. Right? So we're actually getting something. We can go up here. We can do our monitor with Siege for 10 seconds. Okay. We are getting stuff coming through. I probably need to amp up my Slow Loris. But also what you'll see is that, I'm at 1.97, so my server is definitely slowed down a little. But Slow Loris, if you have a get float over the top of it, it crashes a lot faster because you have legitimate requests on top of these never-ending requests. So if we do DDoS Siege 2 minutes, launch that over the top. There's my Slow Loris working. Okay, and I should be able to do monitor. I don't have Siege here. Monitor dash curl dash single. And at some point, if I throw enough traffic at it, throw enough Slow Loris at it, it will lock up and we won't be able to get it. So if you get to that point, and maybe I need to run it a couple times, it'll get there. It'll eventually fall over. It's really slow now. Okay. But that's Slow Loris. Now you can go take a look at it here. And we've got just a couple minutes. So we do File, Open, Slow Loris, right? And I got some unreachable. There's some ARP stuff here. And I want to go TCP.port equals 80. Run that filter. Make sure I run it. There we go. And you'll see here, and let's just do from here to here, follow TCP stream, right? And so what you'll see here is we say get, and Slow Loris adds a random query string. So it's just random numbers. It just adds random numbers to break through proxies. Then we send a couple things here you can actually filter out based on that. And what you get as a response here, right, you'll see it just sends like, here's some bogus stuff. Here, this is actually, this isn't HTTP. It's in the packet itself. It just basically doesn't end. And TCP dump interprets that as text. But that's just bogus stuff for that unending or unended request. And then the web server itself waits, and then it sends a response that says, hey, I don't know what you were saying. I didn't actually get the full request. What's up with that? And then we sent a web page that's it's an error generated by Apache that says, hey, I can't understand what you're saying, and I timed out, right? So the server timed out, and then Slow Loris actually terminates the TCP session, and that's what it looks like. And if you look, close that out, and you'll actually see here's the get, and then you get a reset here. So we send a reset that basically is like, I don't know what you're talking about. And that's what Slow Loris does, right? So if you're getting targeted and you notice that you're getting a lot of these request timeouts, session timeouts, TCP session resets in the context of a larger attack, it could be that somebody's throwing Slow Loris over the top of it.
Yeah, and Slow Loris was known. I mean, if you look at a lot of early attacks by Anonymous, this is one of the tools that they used, right? When they wanted to go out there and attack targets for social social justice or whatever they wanted to call it, social engineering attacks out there. They would use
Online protests.
Online protesting, yeah. So they would use Slow Loris. That's a well-known attack tool as well. So thank you for that, Mike. I'm going to wrap this up real quick. We're running close on time. We've only got 4 minutes, so I want to wrap this up real quick. One of the last thing that we had on our agenda before Q&A was talking about core mitigation techniques. And what it really boils down to is there are 6 specific things you need to pay attention to when it comes to DDoS mitigation, output, and risk reduction. And what's that old thing we used to say, Mike? Multiple compensating controls, right?
Mm-hmm.
Multiple compensating controls is how you approach most IT security problems. If you're not doing that, if you're relying on one or the other, you're doing it wrong, and you're going to get smacked hard by it. So one of the first things we want to do is we want to look at and monitor. We want to look at traffic filtering. We want to look at rate limiting, right? That's something that we can do on firewalls. That's something that if you have IPSs that are monitoring those connections into your web host, you can certainly do that. Number 2, a scalable infrastructure. So diversity and being able to actually disperse traffic among multiple cloud providers or multiple geolocations is incredibly important. So if one goes down or one's attacked, hopefully it'll fail over or roll over into another. So things like Cloudflare, Akamai, AWS Shield, things like that are good to basically redirect those traffic when they detect, a attack. So they do it in the form of auto scaling or load balancing. First time I ever heard that term auto scaling, Nike was a big customer of ours. Q4, they had a special release, and I think this was 2015 or 16, don't recall when. But basically, the release of this shoe took their websites down hard. They had sales. This is what was going on. They were doing all of their web retail application sites in AWS, but auto scaling was literally invented for that event at that point. Number 3, DDoS protection services. So always have something like a Cloudflare or an Encapsula or a Fortinet, right?
And DigiCert. I'll give a shout out to my employer, DigiCert. We do this.
DigiCert. There you go. Yep. There you go. So, something that's always going to detect and neutralize the attacks before they can actually reach your network. That's incredibly important having that CDN aspect to it and being able to detect and reroute. That is incredibly important. I would say number 3 is probably the most important in my view, right? Redundancy and failover, that goes with scalable infrastructure. I view those as very similar, but what happens if we have a hard down, right? What happens if there's an attack and we lose our retail capability in Q4? We're going to lose a lot of money every single hour, every single day that those websites are unavailable to our customers. So we want to make sure that we have redundancy, failover, and more importantly, a plan to get back if we have those types of events. Monitoring and early detection is all about identifying it quickly. And I'll mention this, that 11.5 terabit per second attack that was detected by Cloudflare last week. Their average detection time in there is less than 3 seconds. So just a heads up. That's pretty impressive. And I know, if I was using Imperva, and of course Michael uses DigiCert for his company stuff, and they're all very, very robust and very hardy environments that can absorb and drop a lot of these attacks. And then the final one, and I would say that this is second, only to being able to do that CDN and DDoS protection, is going back and looking at the vulnerable points on a web application. API hardening. APIs are now a top 5 in the OWASP attack structures. They are a top 5 APIs, and the reason this is happening a lot is because companies that are developing or utilizing APIs are saying they're deprecating and they're taking endpoints out of their documentation, but they leave them in the application because they want a backdoor or they want something.
Backwards compatibility.
So or someone has requested a specific, we have automated processes. We don't want to change it. We need this, right? As a customer, they want to do. So at the end of the day, API hardening. Make sure you go back and review those APIs, right? And
Stoner's gonna get the hook. We're in time.
That's it. Okay. Well,
you get like 30 seconds. Go.
No, I'm strategic planning. That's what it's all about, right? Just making sure you stay ahead of the curve.
Cool.
Sam, is that a goon flag in the background?
Yes.
Yes, it is. You know it is.
Yeah, I moved mine downstairs. I might have to put it back up in my office. It really depends on my audience, but I'm going back into being an instructor, not a consultant. So I think it's going to come back up to the office door. That's awesome.
Man, we love DEF CON, don't we, Stoner?
We definitely do. I've told my story, like my daughter joined us this year. So I woke up, I think it was Sunday morning. I'm on first shift. And I woke up to a text from her at like 12:35 a.m. where she had just done shots with the Dark Tangent over at the Rio on the rooftop bar. And I was like, I've never even talked to Jeff Moss, and you're out here like doing shots in the middle of the night. So
That's
she
impressive.
fit right in. It's pretty funny. All right. Thank you guys so much. This was great. It was a really fantastic. I appreciate all the effort you put into the workshop to make this really special today. So it's really appreciated. Thanks again so much for all your time and effort here.
Absolutely. Thank you.
No problem. Cool. Thanks, everybody.
Bye.
All right. We're going to try and get Chris Taylor up here. And I see he just joined the studio. So Chris, you're not live yet. You will want to hit the present button in order to pull up whatever slides or you need to present as well. But I'm about to pull you on screen, so you are about to be live.
That definitely sounds dangerous.
Hello. Welcome to VetSecCon.
Always a pleasure. That's,
So you were doing an in-depth analysis of a fish. And I did say this morning, I believe this was email related and not trout related, but whatever you've got for us.
I mean, we could probably do the other. I'm fine with that.
I think we probably want to stick with the email one though.
Okay, it looks like I'm sharing a slide.
Yeah, I just need to bring it to the screen.
All right.
Give me 1 second.
There it is.
All right. I will let you introduce yourself and take it away. I'm really excited for this one, so pay attention, everybody.
Oh dear God. Don't go overselling it. You'll put pressure on me. I can't handle the pressure.
Get ready for this mediocre presentation.
That's much better. Thank you. Okay. Good morning, everybody. Welcome to yet another exciting time of suffering through me. So I'm Chris Taylor. I am I run a small boutique consulting firm. I have a background in digital forensics and threat intelligence, and occasionally do other weird things along the way. And every October, I go pull something out of my junk folder and use it as a sample for a cybersecurity awareness training for the masses. And last October, it's a slightly dated example at this point. I ran across a particularly interesting phishing attempt that was sent to me. And I thought instead of doing just a presentation for the end user, I would also do a presentation for the security analyst that would be analyzing one of these messages when it gets submitted to the SOC. And so I put all of the content together and then started submitting it to conferences, and quickly realized I had about 4 hours of content, and every conference I submitted it to gave me like a 30-minute or a 45-minute session. So Stoner was polite enough to give me an hour and a half, which means I can show you more of the presentation that I got to do last time, but I still have more content than will fit into this time slot. So I'm going to be talking real fast, and I'm going to skip over a couple of places where I'm going to kind of go a little fast forward at double X speed in order to get through certain parts of this, but I want to try and get you through as much of this as we can. All right. That's kind of the backstory on how we got here. So this is the phishing email that came in. Take a look at this. Show of hands. Who sees anything that might be a red flag to tell you if this is a phishing email or a legitimate message? Yeah. So the first thing that jumped out at me is I run a small company, which means I've got a very small HR department that is run by my wife, and she doesn't own a scanner that sends emails. So I immediately saw that as a from address and was like, oh, nice try, not going to work. And the rest of the body of the message is off. There's a bunch of red flags here. We'll come back to those in a minute. That's really more the user audience version of this presentation, is to go through all those red flags. But the first thing you want to check on any of these spam messages is always go verify that from address. Now you notice the email wasn't there. So to see the email address in the from there, I had to actually click on it. You get this little dialog box to come down. Now we can see that the from address definitely doesn't match my HR department. And you know, that kind of stands out as being something a phishing message would do. If you're using Outlook instead, Outlook is polite enough to put the message, the from address, email address right up next to the display name. This is actually an anti-phishing feature of Outlook that they've added in later versions. It didn't used to do this. It's kind of nice that it does, though. It makes it easier for me to train users on how to spot phishing because they got the from address right in their face. Yeah. And if you submit this into a SOC, what you're going to see in that top of that email address is just 4 data points: the from address, the to address, the subject line, and a date timestamp. And when you submit that message to the SOC, you need to be able to submit it in a way where we can look at the message headers. So the first place I'm going to go as a security analyst is to go look at those headers. In the Mac Mail client, you go up to View, down to the Message button, and over, and there'll be an All Headers button. When you click on it, it'll change because now it's toggling back and forth between default headers and all headers, and that shows you all of the headers for the message. But it rearranges the lines, and they're not easy to read here at all. So I don't recommend trying to do the analysis here unless you just need a quick peek at them. Instead, I would go for the raw source button, cut and paste it out of your mail client into a text editor, and then we'll do our analysis out there in a text editor. If you're using Outlook instead, it's buttons in a slightly different location. You right click on the message, go down to View Source. Now I can see the body of the message. You can also, if you're on a Mac, just drag and drop the message out of Outlook so it's an individual file, and then drag and drop that file into your text editor. And the file is actually a plain text document with an email format file extension on it, so it knows to open it with your mail client. But it's actually a plain text file if you just open it. Now, if you're doing this in Windows, it's going to be a little bit different how you get to those headers, but the concepts still apply, and the view source still shows you the source, and that's what we're going to go look at. When you're reading the raw source on a header, the headers are built from the bottom up. So once you open up the source, you skim down until you get to a blank line where there's nothing. That's the break between the headers and the body of the message, and then we'll read up from there in blocks. And there's 73 lines of data here that is way more than what was present in the message itself. The from, to, date, and subject are down here as 4 lines. If I just hit the forward button and forward this to the SOC, all of these other headers go away. In order for the SOC to be able to analyze these headers, you have to forward as an attachment, or otherwise have the SOC have a way to get to these headers. So train your users that if they send you phishing emails to analyze, they don't just hit the forward button. They start a new message, they drag and drop the offending one in so it's an attachment, and then all of these headers are retained when you receive it. And you don't lose this 70 lines of extra data. Now, reading this is kind of difficult because you are looking at data here that was never intended for a human to read it. It was meant for computers to read it. So it's formatted for the computer's benefit, not for ours. One way we can get through this is to use a custom parser. There are a bunch of these parsers, several of them free on the internet, or there's some standalone ones you can use. One that I particularly like is the Message Header Analyzer, hosted on an Azure website. This one was written by Microsoft, hosted up on Azure, and just handed out free. The whole thing's written in JavaScript that runs browser client side. So you're not uploading the headers back to this Azure website. It's still processing the header locally inside your browser. You cut and paste the 73 lines of header in and hit the analyze button up here, and then it gives us this breakout here. For them, the way they present the data, there's going to be 3 sections here. The first summary block is the same data that we would have gotten visible to the end user who received this message, plus 1 additional line of the message ID. And then the next block here, they've extracted out all of the received lines. We'll talk more about who they are. Basically, this is each of the mail servers that interacted with this as it moved from the sender's message or email client across the internet into my recipient or victim's mail client. And then the third block is all the other headers are just bunched together here, and they're cleaned up into nice, pretty lines. So you see 73 lines of data is actually 16 other lines and 5 header lines, and then a few extra data points. But by running it through this parser, I can't see which of these other lines went with which of these email servers. And there's some other information that's the timestamps in here are going to be localized to whatever my local time zone is. And there's a few other little quirks like that that you lose as you run it through a parser. So we're going to do most of this analysis with by just looking at the raw text instead of using this parser. But this is a great way to read those message headers and get it in a more readable format where it's easier for you to pick out the data. Now, what data are you looking for in headers? And that boils down to basically 2 things. You're looking for the timestamps, the message itself when it was created, and then every one of the received lines is going to contain a timestamp with a time zone. The time zone will give you a clue where in the globe that mail server was. The original time, the one that's actually visible to the victim, is set by the email client that the sender used. So that's whether you trust that one or not, is up to an attacker setting the clock on their own computer or forging the headers as they're creating the phishing email. But they can't control the server's timestamps. So these are a little more trustworthy when it comes to trusting the time zones and the dates that are set on them. And then the other thing we'll look for is any IP address or domain name that's mentioned in here. Every one of these received servers is going to have both a domain name and an IP address associated with it. And then down in the other header lines down here, it will frequently reference other potential domains or IP addresses could pop up down there as well. And I'm going to want to extract all of those out. As I'm pulling the data out of this header, I'm basically sorting all that data into 3 buckets. There's going to be the threat data, the attacker who sent the message, and then there's going to be on the other end the victim data of who received that message. And then in between, there's going to be some mail servers or some other third-party devices that aren't really associated with either end, that are legitimate things that are on the internet that just we're part of relaying the message, but they're not really part of the attacker or the victim. So we've got this, the threat, the third party, and the victim data. And as we're going through pulling out timestamps and IP addresses and domains, we're sorting them into those two buckets. We're then throwing two of the buckets away, and we only want to focus on the threat data. We're not going to be doing reporting and sharing on victim data generally. So we want to stay fixated on the victim or on the threat data as we do threat intelligence. Also, the SPF and DKIM entries that are created by the spam filters, they give us additional IP addresses and domains. And so we'll pull those out of these other headers and find some additional IP addresses mentioned down there that are part of those others. All right. Now, as I mentioned, the formatting is a little bit off on this after it's been parsed. And I want to show you the raw data, and we're going to analyze the raw header in order to try and make sense of it. Because by reading the raw source, we can see some quirks and anomalies that the parsers and our spam filter would have missed and not caught up on. But by reading it ourselves and going to the raw data, we can see those anomalies and be able to spot that something looked possibly off. All right, now when we construct a header, it's the bottom starting point of the header is created by your mail client, and it's going to stick in about 5 or 6 header lines that are going to provide the to, the from, the date, and the subject. And then there'll be a couple of extra lines that will help describe how the body of the message is formatted so that the receiving mail client can properly format it, render it, and present it to the recipient of the message. When you hit the send button, that message goes to whatever mail server you have set as your outgoing mail server in your mail client. And that first mail server receives it. It's going to put in a received line, and then it may add to a few other extra lines depending on how it's configured. And then once it has a bundle of what I'm going to add to the message, it prepins them to the top of the message. It then sends it to the next mail server in the chain as it crosses the internet, and that's going to receive it, add some additional header lines to the top of the message. And since everybody is pre-pending at the top, but they're adding multiple lines at a time, we're reading these messages from the bottom up by going for the received lines and the certain key lines. And then when we hit a received line, we read from there down to see what did that server add. Okay, so looking at this, I can see that the from date starting right about here at content type down to message ID, those are the from to subject date. Those are the ones that would have been added by the mail client. I then go up to the first received line and read from there down, and I can see the lines that would have been added by the sending mail server because it's the first one to have touched that device after it left the email client. And then I can look for the next received line and see the header lines that were created by the next server in that chain. Now, when I start looking through this, our first oddity comes out. There's a received line down here that's out of order. It's not in the location it should be. The other thing to notice, the capitalization is off. It's all caps when all the other received lines are only the first letters capitalized. And the overall formatting of the line is wrong. A proper timestamp in an email header will be day, date, month, year, time, and an offset, time zone as an offset. But we see a almost correctly formatted time, but the time zone is presented incorrectly. So our parser over here showed invalid date instead of parsing this, but there is actually a date there if I get out of the parser and go read it by hand. And then this one that's out of place, it doesn't even have a date. It's just a time and an offset. Definitely weird, wrong, and out of place. And the other thing, a properly formatted received line will be from the mail server that is touching this message. And the first block of information here is going to be how the server self-identifies its own name that it calls itself in polite conversations. And then in parentheses behind it will be the fully qualified domain name and IP address of that server. And depending on how the server is set up, how it identifies itself may be a repeat of one of these other two elements, or it may be just the host name and this one's fully qualified. There's a couple of different variations here that are all considered legit, but generally speaking, this is a network-based name for the device presented three different ways. Down here in our bogus line, the from is victim full domain in hash marks. What's that look like to everybody? My guess here is we're dealing with a form field merge and the double hashtag, and then it's supposed to pull a field out of a table. So there's a table of all the victim data, and they didn't properly populate this, or they didn't properly do the form merge. This should have been the victim's domain here, and they screwed up. So now I've got what jumps out immediately as that's definitely not legitimate name for a mail server. So, and the other thing that we noticed down here at the same location, this message ID. There's a message ID injected here that shows the victim's full domain, and the actual message ID is further up. So there's a bogus message ID down here. And when an automated parser or our spam client read this, it grabbed the message ID that's the bogus one and said the first server to process this was this bogus line. And that would have fed the wrong data into our spam filter as the source of this email address or this email message. So we're able to get around that by just ignoring the parser and do it by hand. Okay. Now, what we're going to do next, we're going to look at the three received lines. The one at the bottom is bogus. So we're just going to ignore that data as not supposed to be there. The next one up is slightly oddly formatted because of how it's identifying itself, and the timestamp being incorrect is a little bit weird. The other thing that's weird about this one, a normal received line will be from a server by another server, and it usually receives across a network because these mail servers are usually talking across a network. This one is from a server identified by its IP address by and whatever this is. And that's not a network address. So I have no idea how this mail server received this message, but it does not appear that it received it from across the network as if it was a legitimate mail server talking across the network to a mail client. It kind of looks like a memory address. So my guess here is this was received as an inter-process communication from two apps that are on the same computer talking back and forth by memory addresses instead of through the network stack, is what my guess is as to why it received it from a weird address. And then the third received line in our parser is the actual mail server that sent me the message. So my read on this, what it looks like, the message is coming from rentechsolutions.com, and the third received line in our chain is the actual mail server associated with rentechsolutions.com processing this message and forwarding it on to our victims. And the second received line here with an IP address that seems odd and off and not like a legit mail server, I think this one is the machine controlled by the threat that's actually generating the messages and sending them off. Make sense? Y'all with me so far? All right. Then what else are we looking for in here? In addition to the three received lines and the IP addresses and domains, we also look at the SPF, DKIM, and other spam filter lines that are added in. These give us additional information about how this message was processed as it was sent. We can see here that it did pass both the SPF and the DKIM checks. What does that mean? Passing the SPF check does not mean it's not spam. Pass here means it's not spoofed. So the from address down here, the actual from address was support@rentechsolutions.com. The mail server that sent the message did a check on the domain DNS table entries for this domain, and there's SPF entries as a text field in the domain, the DNS table for that domain that says who's allowed to send mail as that domain. And the mail server, the IP address of this mail server is one that is designated and allowed to send those messages. Therefore, it passes this. So I know this address is not being spoofed. Now, attackers could have rewritten this address in order to make it more likely for me to think this actually is a scanner in my org. They could have put scanner at the victim domain here, but it would have then failed the spoof check, and it's more likely that my spam filter is going to throw it in the junk drawer. So most attackers aren't going to do that. They're not going to spoof the from address if they can, because it's more likely to get through the spam checks if it isn't spoofed. So they'll rely on just changing the display name and leave this as a bogus address for us to see. And now they're relying on the human to not look at the address and take that extra step of paying attention. Luckily for us, users are always paying attention, right? The other lines that we're getting into, there's 2 more received lines down here, but at this point, we're getting closer to the victim and further away from the threat, so these don't really apply to our investigation. The lines that do help us, though, are the 2 received lines and a couple of extra lines that were added by that mail server that give us additional IP addresses, or they validate an IP address, because I'm seeing the same address mentioned multiple times. So I have here a sending IP address, and I have the IP address of the oddly formatted received line. That gives me 2 IPs and domains to go look at. The first one, that's a legit mail service. So I may adjust the reputation associated with this and say this is now known to send spam, but it's a legit mail service. I'm not going to block it, or I may shut off legitimate messages. This other IP address, though, it looks suspicious. I want to investigate it a little further because I can't tell what this is. And when I want to investigate an IP address, I want to be able to go look it up in Whois. I want to do a reverse DNS. And I mean, the mail server already did it for me here, but I want to validate it to see if I get a different answer. And I'm going to do GeoIP lookups and a few other things. I can do all of those tests at the same time if I just throw the IP address into Shodan. So go to Shodan, drop the IP address in, hit search. You get back a page that looks kind of like this, and it's done all of those tests and more in one search engine. So this simplified a little bit of my research. And from that, I see this reverse DNS gives me basically the IP address in an oddly formatted as a domain name. And when you see an IP address as part of the domain name, usually what that indicates is this IP address is part of a DHCP pool. So your internet provider that's providing your home connection, your home IP address may change periodically over the time that you live there. And this way, if you did a reverse DNS on that DHCP provided IP address for like your home or a small business, then this is the kind of a domain name you would find associated with that, with the domain being owned by your internet provider, whatever your ISP is. Doing a search for who owns this domain tells us it's owned by OVH SAS, and doing a GeoIP lookup tells us it is in Frankfurt, Germany. And a little bit of Googling on both of those things tells me OVH SAS is a cloud provider, and I'm looking at a virtual machine hosted in a cloud services data center out of Frankfurt, Germany. And then Shodan went and did a few other things that tell us a little bit more about this. When they did a port scan on that box, they discovered that it was a Windows Server 2022 version. And the host name is win dash bunch of random characters, which is basically a default host name that computers, that Windows will give you as you're installing Windows Server. It's using a self-signed cert, and it has 3 services as open ports exposed to the internet. And RDP, I recognize that one's pretty common. What are these other 2 port numbers, 5357 and 5985? Does anybody know what those 2 services are associated with those ports? So I had to Google it. I didn't know. And what I figured out was those ports are associated with WSD API and WinRM. But what is WSD API and WinRM? So I threw those 2 into a Google search. And what I found was WSD API is the Windows Server Device API. That's what Network Discovery uses. When you open up a Explorer window and you go to the network button and it shows you the other computers that are on the same LAN as you. This is the API that Windows uses to talk amongst itself in order to figure out that there's other devices on the same LAN local network as you. And WinRM is the remote management API used for things like WMI and PowerShell. Both of these are services that are supporting local networking between this server and other clients or servers in the same network. These are things that should never be exposed to the internet. And the other thing I learned when I Googled just these 2 words, within the top, one of the top 5 hits in the Google search was a GitHub page with mentioning details about a CVE and proof of concept exploit code for both of these services that says that right here, and there's a demo if you watch this video, but I couldn't get it to fit on the screen, so you don't get to see the demo. But there's there's an exploit for these services that lets an attacker break into and take control of a Windows server if it has these services are vulnerable. And here's the exploit code to try and break it. So I have a theory at this point. My theory is this is a VM hosted in a data center in Germany that has not been hardened. It's a default install of Windows. Had it gone through the extra hardening that you're supposed to do before it's exposed to the internet, it would have had a non-default host name. They would have possibly changed the cert to the not a self-signed one, but a different one supplied by Let's Encrypt or somebody else. It's got its services. All 3 of those services are things you shouldn't expose to the internet, and they are. So that's another clue that this isn't hardened properly. And so I think that our bad guy discovered this machine, used this exploit, broke in, took control of it, installed their spam generating toolkit, and is now using this machine to generate the spam out to the world. So this machine is actually a victim, not the actual threat, but it is a victim who is being misused by the threat as part of their attack infrastructure now. They're sending the messages from rentechsolutions.com, which means they have stolen the credentials for the account support at rentechsolutions.com. That's a second victim that is being misused as part of the attack infrastructure. So they are misusing this victim and then generating emails, logging into the mail server for Rentech Solutions and misusing that victim. And that's how their messages are being sent out. At this point, I still don't know anything about the threat, but I have identified 2 additional victims, and I know the attack infrastructure being used to send out this spam. Make sense? All right. Then out of the headers, let's go back to the message. The message had an attachment on it. To analyze an attachment, we get it out of the message. We just drag and drop it out of the email, so it's a separate file. And then we start analyzing it with basic digital forensics techniques. The first thing I'm going to do is get hashes of the file, and I run it through a tool called EXIF tool, and that tells me about the internal metadata inside the file. from the MIME type down in the EXIF tool output is internal metadata inside of the attachment. The data above that is about my file system on my forensic machine. So this doesn't help me understand the attacker, but the bottom part does. And when we look at that bottom part, I see 3 timestamps and I see some other text in here that is potentially helpful to me. The timestamps, we'll start there. I've got a create and modified time, and they are exactly the same to the nanosecond. That tells me this file was spawned and then not modified a bunch of times after that. The revision number here set at 1. That tells you how many times the users opened up Word and hit the save button. Okay. The create date is associated with when you've got Word open and you hit the new button, poof, there's the document. And then when it's time for you to save the document to a file, it usually will, the document gets zipped up into a zip package and then turned into a Word doc file on disk. And we have a zip modified date and we see when that action happened. This timestamp, if you remember what was the timestamp in the headers? Does anybody remember? It was only 3 slides ago. Surely you remember the headers. All right. So this timestamp is within a few seconds of when the email was sent through the mail system. But this timestamp is about 3 hours and 45 minutes, roughly, 44 minutes to be precise, but it's about 3 hours and 45 minutes prior. So what it looks like, if we assume that all these timestamps are Zulu, we know the timestamps in the header because they flat said they were GMT or a -0 offset. So we know that was in a Zulu time as well. So we see about a 3-hour time process here. What that sounds like is they have a big table of victims. They turned on their software and said, here's the mail template to use, go. And it's run for 3 hours and 45 minutes before it got to my name on the victim list and generated the email to me. There's other possibilities, but that's what that timeline looks like as we're reading these timestamps. The other thing that we look at is the creator and the last modified by and some other data blocks here. Normally, this would tell me a user's name and which version of Word was used to create the Word doc. So instead of telling me that, it says HTML to docx. And HTML to docx, if we go through that in Google, I find that that is a JavaScript library that takes an HTML input and creates a docx file format output so that I can take a web page and dynamically generate a Word docs out of it. So that is a guess. I don't have hard clue here. I have a line in the metadata that could be changed by an attacker. But at this point, what it's looking like is that OVH system, the toolkit the attacker installed there, includes this JavaScript library, and they have a table of victims. They have a HTML formatted attachment. They've got a template for the emails, and they're doing a mail merge where they dynamically generate the attachment, dynamically generate the mail message, put the two together, and then send it off to the mail server to be delivered to the victim. We want to analyze the internals of this Word doc. The first thing we're going to want to check is to make sure it doesn't have any malware embedded in it, so any URLs that are going to cause it to go pull content down off of the internet, or so we just want to make sure there's no macro that's going to blow up our machine. Because docx, the open document format, is an XML inside of a zip file, you can just change the docx extension to zip, unzip it, and you'll see this folder structure, and then you can go read the XML files. If there's executable code or JavaScript or any other type of code embedded in here, you'll be able to read it. And so we can tell this doesn't have any code in it, so we're going to it's safe for us to view. So this is what it looks like inside that document had the victim actually opened it. And this is obviously a very legitimate message from my HR department because it has my logo in it. So I very much trust this and will do everything it says because they included my logo. Nice try, bad guy. So this becomes a clue. My logo is normally a banner. There's only one place on the internet where my logo is squished up into a square, LinkedIn. So that tells me how our attacker is getting their victim list. They're scraping LinkedIn looking for victims and then pulling names and dates, etc., off of LinkedIn in order to pick their victim list. And then they're sending it off from that. There's a date, your attention in this document. The email said they were sending me a document, but when I open this, this is obviously not the document they're telling me about. Instead, I have to scan this QR code to see the document in question. So I already am kind of primed, kind of like that pretexting we talked about yesterday, right? I've already been kind of primed in my head as the victim that if I scan this QR code, I'm being redirected to SharePoint. So I'm going to expect a Microsoft login prompt. Right, so they're setting me up for that ahead of time. The other thing to notice, because there is a date, there's my email address and a logo in here. If there's 20 different victims within my organization all receiving this same message, they're each going to have a unique attachment. So I'm not going to be able to search for this attachment across my enterprise for 20 different victims by the name of the document, the file size, or the hash, because it's going to be different for every single victim. So normally that's a tactic we would use to find if this file was opened by other victims, because phishing emails rarely go to one person. They usually go to a bunch of people. So we'll want to go look everywhere else. And that tactic won't work by looking for the attachment. I'll have to look for specific strings. I'll find a string in here that's unique and then go look at every Word doc for this as content inside the Word doc, which is a lot more painful search to do, but that'll lead me to the file. All right. Now, to figure out what's behind this QR code, ironically, we're going to do exactly what it says. Scan it with our smartphone, because that's the easiest way to decode a QR code. So you point your camera at it, and you're going to see this big yellow dialog button pop up. Don't click the big yellow button. That's a trap. Instead, you want to hit the little icon off to the side. And when you press that little icon off to the side, this menu opens. And now you can see the URL that's embedded in the QR code without actually opening it from your phone. You can also then hit the copy link, paste it over into your notes, and so that you don't have to, because sometimes these URLs have a bunch of numbers and some kind of a session ID code or something. So trying to hand type them is a bitch. Use the copy paste here so you don't typo something. But this way, you don't want to open the link from your phone. You have less malware protections on your phone than you do from your workstation. We're just using the phone to get the URL out of the QR code, and then we'll go back to doing the analysis on our workstation again. There's so this gives us a domain and a full URL, and we're going to go analyze this domain. Yeah, excellent point. You can use other things on your desktop to parse the QR code as well. And because the QR code was just an image, it's super easy for you to just pull this image out and drop it into CyberChef or some other parser if you want to do it that way. Analyzing the PDF sharing file domain that we saw in that URL, we go do a Whois is our first stop. We're going to pull up the Whois data for us. There's dozens of Whois servers on the internet. I'm just using the one that's the shortest number of letters. And the top half of the Whois data tells me that when was this domain registered and who is the registrar that it is, the DNS servers that are hosting it, etc. It was registered just a few days prior to receiving the messages. So this is a newly registered domain. Based on it being a newly registered domain and the name of the domain, it looks like this is infrastructure the attacker set up just to be part of this spam campaign. Further down, I have to scroll down because it wouldn't all fit on one screen, but the bottom half of that is going to be contact information for whoever registered it. A lot of times this is going to be anonymized, but in many instances, you'll have date, names and addresses, phone numbers and email addresses in here as this registration information. Now, usually that's anonymized, so it's kind of fun to actually see that the bad guy put data here. Now, the data here is probably bogus, but there's a couple possibilities on what this data is. It could be that the attacker has hijacked an existing domain. If you hijack an existing domain, then the name would have been incongruent with the idea of sharing files, and the registration date would have been years prior, and the URL would have pointed to a hidden page on a legitimate website, which is not the case on this particular URL. So I don't think that's what's happening here. I don't think we're hijacking a legitimate domain. It's also possible the attacker registered this domain, filling in a bunch of bogus information. But how bogus is it? It's they had to pay for the domain somehow. So some of this information has to match the payment information. So they likely are making up these middle bits, but the zip code and the name are probably aligning with a stolen credit card or some other type of payment method, so in order to pay for the domain. So I think what we've got here is a third victim who is going through some credit card fraud. And the third possibility of what this data is that the attacker just used their actual name, address, and phone number. But that would indicate that we've got a really stupid attacker. Not likely. What we can do, though, is even though we think this is bogus information tied to a third victim, not using the free, and I have been limiting all of the tools I'm showing you through this whole presentation are free. If we shift away from free stuff and go into paid stuff, you can do whois searches by email address, phone number, or any of these other fields. So this is a lead we're setting aside for later. I want to go look up where else has Ellie Scott, Macbeth Group, this phone number or this email address, what other domains have they registered? That might lead me to other domains associated with the same threat actor. All right, so set that aside as a lead to follow up later. The other thing we want to look at for this domain is the DNS records, because I want the full list of IP addresses associated with it. If I open up my computer and just do a ping or a DNS lookup, I'm going to get fed back a single IP based on where I am in the world and how my network stack's configured. I want to know all of the IPs that every other victim might see, not just the one that's most convenient for me. So we go to the DNS records and we pull up the full list of IP addresses that this could resolve to. And then I now have IP addresses associated with that domain. That'll come into play at some point as well. Okay, so that is the URL. Let's shift off of analyzing the URL by itself and look at the actual website that opens when you click on that link. Now, I don't want to just go to that website directly. So I use this the service urlscan.io, and I make them go to that website on my behalf. That way, if the web page is going to try and exploit my browser and break my machine, it can break their machine instead of mine. Saves me a lot of trouble. But there's a big, huge caveat of but with this. You want to be careful not to expose victim PII if you're uploading anything to any of these public services. I can't upload that Word doc to VirusTotal because it has victim PII, an email address and a name in it. I can't just dump this URL into VirusTotal or into this service directly. I can't use the public QR code scanners because I just gave away my email address to that scanner. Right? So you have to be very careful about exposing public PII or victim PII publicly. So we want to do this as much as we can on local services that aren't going to capture and potentially share that data. And then I can modify the domain here, the victim email in the URL, and submit the URL up with the victim PII minimized out. That way we can protect our victim as we're doing our analysis. A lot of these public services like VirusTotal and URScan are monitored by the attackers, and they will watch for their malware or their websites to start showing up in those public scan tools, and then they'll know that these security people are onto them, and they'll start shifting their tactics to stay hidden from the security team. So we don't want to tip our hand too soon with certain types of analysis. So be careful about using public services like this until you're ready to tip your hand. All right, so I dumped the URL in, and URLscan is scanning it. The first thing I'm seeing here is this cool screenshot of the website, and I've got a CAPTCHA here. So the CAPTCHA tells me that it has thwarted this automated scanner. I don't get to actually see what the website looked like. I think maybe that means that URLscan is a robot, since it couldn't click the checkbox. The other thing that stood out was that Google Safe Browsing is already flagging this domain as malicious. And at this point in my analysis, I'm only a few hours after the message was received. And so this is still an ongoing campaign, and it's already being flagged. So if you're using Google Safe Browsing to help protect your victims' browsers, they would have been protected if they clicked on this link and actually tried to do what the attacker was selling them to, even within a few hours after it. But there's always a window before it gets flagged as malicious where the victims are completely unprotected. So, woo, we're already safe. Yay, us. Right now, since this didn't let me see what the actual web page looked like, I needed to shift over to a malware sandbox that I controlled. I'm not going to do this from my machine because I still don't know if this site, once it gets past the CAPTCHA, is going to deliver malware. So we're not going to do this on a just my normal workstation. You set up a virtual machine that's isolated from your internal network with malware analysis tools on it. If you're not used to doing this, go get some training first. But that way you don't accidentally set off the I love you virus on a corporate network. Not that that's ever happened to the NSA. So once we're on a malware analysis workstation, we can open up that browser window, go to that URL, and this is what we see. It's as I kind of expected when I looked at the QR code in the Word doc. It's a Microsoft login prompt because of course I have to supply my username and password to log into SharePoint and get the file that HR is sending me. So the fact that it was a Microsoft login prompt was not surprising. This is a credential harvesting campaign where they're trying to steal my Microsoft credentials. The part that was surprising was that it was so bad. This is actually a pretty ugly login prompt. And a lot of times the toolkits that produce this login prompt that the attacker can go buy on the dark web and then use as part of their attack methodology is usually a really good, faithful copy. Most of the phishing campaigns I look at, this login prompt is perfect to the letter with the legit Microsoft login prompt. This one is not. It's actually quite ugly. I'm a little disappointed in them. I expect a higher class bad guy to be coming after me. This one's disappointing me. A couple of ways you can tell that this one is faked. Let's zoom in to show texture and compare it side by side to a legitimate real login prompt. The fake has this text underneath it that's not supposed to be there. Forgotten my password is grammatically incorrect. The title of the page is a random word with no icon on it. And the most glaring thing that even if they do change, if they do get a good toolkit where they have a really good copy, even if they get all of the body correct, they can't fake the URL. So always check anytime you're prompted for a password, go back up to the address bar here and make sure you're still on the domain you think you're on. If it's a real Microsoft login prompt, it's going to be at live.com or at microsoftonline.com or microsoft.com, or there's about 5 or 6 different domains that Microsoft uses for their login prompts, and it makes me want to drive to Redmond and throw eggs at their building. Pick one so that I can train people on what to look for. They don't want to do that, but it's going to be one of a handful of domains that are very obviously tied to a Microsoft service. When you start seeing, Sally's Baking Blog.ru over here as a domain name, you know you're on a fake website, and you should back away instead of entering your email address. All right, so let's take a look at this bad fake login prompt. It already had my email address entered because it was in the URL when I submitted it. So it skipped past the prompting for a username and went to the asking for me for a password. And when I entered a bogus password as part of the test, it told me my password was incorrect. That gives me an indication that what this toolkit is doing is proxying the login to Microsoft's website. And then it's passing up the username, it's passing up whatever password I enter. And then if there's an MFA prompt, the MFA prompt, when it comes back from Microsoft and either sends me the text message with the code, or I open up the Microsoft Authenticator app and type in the code, they're able to capture that as well. And once I complete that second or third step on this fake login prompt, they now have a credential that works. And if it's protected behind MFA, they're going to receive the cookie from Microsoft, set it aside, and then the threat can come along, pull it out of their toolkit, drop it into their browser, and they're now authenticated as me on Microsoft's services. So even though it's protected by MFA and they can't use the password, because of the MFA token being different every time, by getting a good authentication cookie, they have anywhere from several days to several months that they can stay logged in as me by dropping that cookie into their browser. Right now, when I right click on this and use the web developer tools to view the page, I can see the content of the page. And even though it's claiming to be a Microsoft login page, I'm seeing references to self-driving cars and vitamin C and crap that is definitely not a Microsoft login prompt. And that's camouflage. When a web proxy or a spam filter looks at this web page, they're going to see that text. And when it's time to see text like enter password and sign in, those kinds of strings are broken up like this. And that's a way to hide from those automated tools so that they don't see keywords like password or sign in or log in or whatever. So this is an evasion technique where we break the text up into individual letters. We fragment the strings and then nobody can get through it. All right. This is a live view of the page using the developer tools in my browser. If I were to right click on the page and go to view source, I would see the page source as it was delivered across the network. And when I do that, this is the page source that I see. And this page source is very different than what was rendered in the browser. So something is changing the content live inside my web browser. I'm kind of curious what that is. It's weird. It shouldn't do that. Normal websites don't do that. What's going on here? So the answer lies in this JavaScript that was delivered into my browser from the PDF sharing file website. And to understand how this JavaScript works, I pull this JavaScript out and I'm dropping it into a text editor, and I'm going to reformat this to line up the various parentheses to make it a little easier to read, which means I'm going to, for the purposes of showing you what happens inside this script and to give you an idea how you would reverse engineer a script like this, but we're going to look at it outside in a notepad just so that we can see what's actually going on. That JavaScript on that page is 2 functions, factor and ukulele, and then there's an if statement. The if is basically checking the CAPTCHA. If you've passed the CAPTCHA and proved you're a human and not a robot, run ukulele. So once I get past the CAPTCHA and I prove I'm not my spam malware checking this website type service like VirusTotal, URL Scanner, or any of those other automated ones, we get past the CAPTCHA, we run ukulele. And what does ukulele do? It is a document write and then a factor and a fetch and a factor and an ATOB, all nested inside each other. And when you're in programming and you have nested parentheses inside of a single line like this, in order to parse it, you go to the very inside set of parentheses and start working your way out. So we will start with ATOB because it is the innermost command. And we're going to step through each one of these commands to see what this JavaScript's doing. ATOB is a base64 decode. It's taking ASCII to binary. So here's a string of ASCII characters. We run it through a base64 decode, and we get back whatever the original source was before it got base64 decoded. And what we find inside that block of characters is a 4-variable JSON list that is A, B, C, D with some content for each one of those variables. And now I'm going to pass that as input to factor. Factor is our other function that we defined up here. So this whole thing is getting dropped into factor, and then it's parsing those 4 variables into, so these 4 bits of content become the 4 variables in this routine up here. In order to make it easier to tell what those things are doing, I'm just going to replace the variables with what the content was that was passed to them so that we can see what's going on up there. And what we've got going on up here is PBKDF2 is going to use several of those inputs and do something with them. It's going to do a hex parse. The hex parse says, treat this ASCII string as if it is hex code and turn it into a number, a binary blob instead. And when we do that, we convert the first line into the word karate and then 0x and a string of hex. We've now got a binary number, a big bloppy looking number here and a word. So this is a password. This is a salt. And this is instructions for how to hash the password with this salt in order to generate a key. And then when I run that routine, I end up with this binary number. This is the key that AES Decrypt is going to use. So now I've got encrypted data, a key to decrypt it, and an initialization vector. So now I can go through an AES Decrypt and decrypt this junk, and I end up with this blob of binary data. Once I get this blob of hex code, I pass it through toString, and I convert these hex into UTF-8, and I get back a URL. So all of that was using AES to encrypt a URL so that I, looking through the web page, couldn't tell what URL I was going out to pull data from. All right, but we've decrypted that. We now have a URL. We pass the URL and the return back down to our where we called it from, and now we're doing a fetch. So now our browser is going out to this URL and is going to bring back data. It's going to use a post command to do it, not a get. The reason it's using a post, that allows it to pass additional variables in the HTML header as it's going up. And posts don't show up in your history as a page you browsed to, and a get will. But that's an ancillary. What they really want is the ability to pass variables up. Ukulele equals quadriceps. If I were to take this URL and just go put it in my browser, I would see different information than if I were to put this URL into a post with this extra variable. So that extra variable ends up acting as a password so that any kind of automated scanner that just pulls a URL out and checks it won't see that it does something malicious. So I get very different content if I just go view this page than if I were to do the post with this password. If I do the post with this password in there, what I get back is 4 variable JSON array. And I had to shut off word wrap because at this point, this blob here is almost a meg. It's several hundred kilobytes long. And then the other 3 variables are really short. All right. And now we're passing it to factor and we're doing the same thing a second time. So we pass those variables up into factor and we do the same thing we just did. And what we end up with is a password of cadmium, a very small salt this time instead of the really big salt we used last time. So bigger data, but less protected. They're relying on the obfuscation of you probably didn't get this far. And once we know the key used to decrypt and we pass that in, we're able to decrypt that big, huge blob of data. And the big, huge blob of data becomes HTML. And when that HTML gets fed back to document write without specifying which element you're writing to is going to default to the HTML element, the whole web page. So I'm going to pass a huge block of HTML, an entire web page, and this document write is going to gut whatever PDF sharing file presented to me in my browser and replace the content with whatever Speedy Gonzalez, whatever that URL was, into the contents of my web page. So the fake login prompt is not coming from PDF sharing file, it's coming from the other domain. This is the web page that came down to me. It's an automotive design website that references cars all the way through it. If we render it in our browser, this is what it looks like. But if we let that JavaScript swap the content out and do a post with those extra passwords, we get a login prompt instead of this design website. So this design website is camouflage used to hide from tools like URL Scan or FireEye or any kind of website checker that your spam would use to validate a web page. All right. So that's what's going on in that web page. I now have another domain I need to go check. That gets me some more IP addresses and another URL to add to my pile. I go past that to URL Scan. Notice this one is not blocked because nobody's gone this far with this data. They've only blocked the first one, not the second one. Another cool trick you can do with URL Scan is there is a similar button you can hit here, or you can strip off the subdomain, and let's look at the top level domain, and we can do some others tests inside URL Scan. If I look at this, the domain without the subdomain on it, in URL Scan, that domain has been scanned 162 times. And if I look at the screenshots of those other 162 pages, I see the same car design website or CAPTCHA or login prompts 162 times. So here's another lead that we're not following, we're going to set aside and come back to, is other domains at xnet.su that are all the same toolkit being hosted out there. And if I go look, I find they're not all hosted at the same web server. They're scattered all over the place, even though the same domain might be directing each subdomain to a different hosting server. So that's how somebody is selling off this service to people who want to buy it. Getting back to our fake login prompt, I've answered one question. Where did the login prompt come from? I have a second question I want to answer. When I hit the sign in button, who am I submitting my password to? Is it the same domain or is it a different one? To answer that, I need to look for this button in the HTML code. I find the sign in button, and then I get an element ID for the name of the button in the HTML. And then I go find the post command associated with what happens when a user pushes this button. And I ended up finding this post right here in that code. It was too hard to read in the browser. I had to cut and paste it out into an IDE. And the URL that's getting posted is zygotic, which is obviously not a URL. What the hell is a zygotic? We find a variable named zygotic being defined right ahead of that function. And the variable is A to B. Again, we're binary base 64 encoding something. And what this is saying is go to the element named Wanderlust, grab the value, run it through a base 64 decode, and then store that in the variable zygotic. And then come down here. When you hit the button, you're going to go to that URL. So now I got to find Wanderlust and figure out what is the content at Wanderlust. Did a search for Wanderlust. I find this string of garbage. I throw that into CyberChef, and I get back a third URL to look at. That third URL happened to be the same domain, speedypassportxnet.su, but instead of the going to the index.html without specifying a web page, now we're specifying 6087.php. So now I have a second URL on the same domain that is associated with our attack infrastructure here. At this point, I'm starting to run out of time. John was nice to give me more than 45 minutes, but I still don't have all day. So let's wrap this up. What have we learned about this website so far? This is it's pulling from PDF sharing file. It's then swapping the contents out with a fake login prompt being fed from speedypassportxnet.su. And then when you hit the submit button, when you type in your password, you're submitting your password up to 6087.php. Index.html and 608, they are slightly different. They both use the same car web design camouflage, but the JavaScript on this page is different than the JavaScript on this page because it contains the code for how do I accept and store the passwords the victims are supplying to us. It's using a bunch of camouflage and obfuscation to hide from our security tools and anti-forensics to make it hard for me to analyze. And it's using base 64 and AES as the primary tools to hide that data from us. This is what we've learned just from this one phishing URL. All right. So what's going on in this entire process? I have received a phishing email. It's pretending to be from a scanner. The body says it's from the HR department with an employee benefits document, and I really need to open that because I read every single email my HR department sends me. When I open the document, I find my logo and my email address, which makes me feel like it's legitimate. There's instructions to scan a QR code. I scan the QR code, and then my phone is immediately redirected to a Microsoft login prompt. I fill in the login prompt. I hit the button. I receive the text message, or I open up the Authenticator app, and it auto-fills my MFA code. And now I've just compromised my account, and the attacker has my username, my password, or an authentication cookie, and I'm able to be victimized. What have we learned doing this analysis through that entire process? What did we find so far? Those of you that were taking notes, how many of you were taking notes? Killing me. None of you wrote any of this down, did you? So the IOCs that we've been collecting through this entire analysis process, the first IOCs we collected were the from address, and there's 3 data points here. There's the display name, the full email address, and the domain of the email address. And I can use that 3 different ways in my spam filter or in my other searches later on. We've got the subject line. It has a date on here. So if I go searching for other messages from this same campaign, I'll have to use a partial subject line, but because this number may change over time, but I've got a subject line I can use. We have the sending mail server. And we have an attachment. And normally this attachment is something where I would say, go scan your enterprise and see if this document or a file with this hash shows up on any other computer. But during our analysis, we discovered that this is going to be unique per victim. So this doesn't really help us this time, but it very likely helps you in 80% of the other phishing emails that you get. Doing a trivial amount of a little bit more work, by reading the headers, we learned another IP address that our spam filter would have given us the wrong sending email server. And I got an additional IP address by parsing the header by hand, and the QR code. A couple of them do, but most spam filters won't parse the QR code. So it would not have given you the here's the phishing site URL you should care about. So by doing a trivial amount of let's read the headers, let's check to see what's inside this QR code, we got extra IOCs. So I can be more thorough in my searches for emails from this campaign or associated phishing emails coming from the same attack infrastructure. And by analyzing this website and the fake login prompt, I got 2 more URLs and a bunch more IP addresses that are a known bad associated with the attacker content that I wouldn't have gotten had I not gone and analyzed that website. Now, even if you didn't decode that JavaScript by hand, you still could have collected this just by having the recording tools in your malware sandbox, recording all of the web traffic coming off of your browser when you open the website. So you don't necessarily need to do that level of decode by hand, but by having a malware analysis workstation that's recording all of the process, network, registry, etc. activity, and then I drop the URL into my browser and hit go, and it tells me here's all the websites you visited during that 5-second time span, I'll know about this extra URLs, and I'll know I can do the analysis on this domain and get all these extra IPs. And this doesn't include the 2 extra leads that we didn't follow. We were going to follow up on who registered this domain, which will potentially lead us to more domains. And we need to follow up on xnet.su with different subdomains. And that'll potentially lead us to, because every one of the subdomains has a different set of IP addresses. So that'll potentially lead us to thousands more domains and hundreds more domains, thousands more IP addresses that are known evil associated with this campaign. Once I have this giant pile of here's all the IOCs associated with this campaign, what do I do with them? The email addresses, the email domains, the email subject lines, the sending server, the attachments are all things that I can load into a spam filter and search. Spam very rarely goes to a single person. It's usually delivered bulk. So there's very good likelihood that 5, 6, 12, 20 people in my enterprise received the same phishing email. So as soon as the first person hits report as phishing, I do this analysis and then pivot right back into search everybody's inbox for messages from this or with this subject line. Here's 12 other victims. Let's go delete that out of their inbox before they even read it. And I can proactively protect them before they even realize they received a phishing email. The domains and IP addresses and URLs that we received, I can load them respectively into different perimeter security tools. I'll block the IPs at the firewall. If you've got a fancy next-gen firewall, you can load both the DNS domains and the IPs into your firewall. But traditionally, firewalls are layer 3, so we would load the domains somewhere else. If we have a web proxy, we can use that to filter the URLs and the domains. If you've got a local DNS server where you are resolving all of your DNS lookups for the clients on your networks through a DNS server that you control, use DNS black holing and load those known bad domains into the black hole zone, and you can protect your environment. This is one of my favorite security features because it's basically free. You just got to go configure your DNS server with a black hole zone, and you've added a layer of filtering to your world. Then the only work you have to do is to maintain that the known bad zone, and there's automated scripts for doing that, and you don't have to buy a security tool. You can do it with your own existing infrastructure. Cool way to do it. Your endpoint security tool, your anti-malware, your EDR, whatever you're calling it, the agent on your endpoint that knows how to block malware, or you load the attachment, hash, name, etc. into that. Then even if the user does click on the link and downloads that Word doc, your anti-malware process on the endpoint can prevent you from opening the known bad document. So you want to load those hashes in as custom signatures in there so that you can block those for your people. And then the final step, take that big pile of data and share it with your friends. If you're receiving this campaign and you're not telling anybody about it, then you're not helping your neighbors protect themselves from this same campaign. That campaign went to potentially millions of addresses, definitely hundreds of thousands. If I share this data with the community and various other security researchers can start doing this with that data before they even see these messages come into their environment, that allows other people to proactively get ahead. It's inoculating yourself from the internet. Then the final bit goes back to what would this presentation be if I was talking to users instead of other security analysts? What are the red flags that we should have been telling our users about so that they could tell that this was phishing? There are a bunch of red flags on here. Check the from address, look at the to address. I'm expecting a message from HR. If it came to my home address, that is incongruent with the message. If the message is your Netflix account is broke, and I look up here and it's my work address instead of the home address I signed up for Netflix with, there's a disconnect there. So checking the to address to make sure the message matches the account you expect to receive messages of that type on. The subject line is weird. The date format isn't a US date, but I'm a US company. The greeting is off. They're greeting me by company name. That's exactly how my HR department greets me all the time, especially since my HR department is my wife. So usually my HR department messages are, hey, honey, look at this. Grammar and structure oddities in the body of the message. In this particular case, the biggest there were incorrect grammar and weird structure here, and the disconnected file name. They say they're sharing a PDF, but there's a Word doc attached. So even without opening this, I've got a bunch of red flags that say this is phishing, don't open this. The attachment could contain malware embedded in it, so you don't want to open this up to check it. You want to look for these red flags first and go ahead and mark it as phishing here. Even if your users miss this step and they do open it and they do click the link, because some of your users will, they get presented this phishing site. How would they have known this was a legitimate phishing site and to not fall for it? The red flags here, the address bar is not the place that this login prompt should be. The page title is weird letters instead of what I would expect on a legitimate page. If you've branded your Microsoft login prompt, you have your company logo here and you have a custom background, it makes it harder for attackers, because if they send phishing emails to your users and your users click the link and they see a generic Microsoft login prompt instead of the one with your branding all over it, that can be a thing you train your users on to help spot these fakes. And so the most important part of all of this is anytime you're asked for a password, always go check the address bar. Make sure you're on the site you think you're on. All right, so that's it. That was the end of it. Or is it? Not really. We're going to keep receiving more phishing emails. So it'll only be the end when phishing stops. But that's this presentation. I think I have like 3 seconds left for questions.
Yeah, we can see if anybody has any questions for sure, Chris.
What you got? Me. Nothing. It's dead silent out there. I have put everyone to sleep. Excellent.
Definitely not. There was people commenting the whole time.
Yeah, I saw it scrolling by. I was just talking too fast to read any of it. Yeah, this is like 4 hours worth of content presented on crack. So
No, this was great. Tyler does say, did you want to mention anything about man-in-the-middle proxy analysis of your network traffic?
Yeah, that's I can. There's are we talking adversary in the middle as the proxy, or me setting up a proxy? Because those are two different things that you can do.
Yeah, analyst in the
As
middle.
an analyst, if I set up a web proxy and then I start seeing logs of all of my users' web traffic as it's flowing out to the internet, that is an amazing data source I love and highly recommend if you can get it. Most of my clients don't have that infrastructure in place, but when we do get it set up, I'm looking at that every URL that goes by, I pitch it over to a threat intel service and go, is this domain associated with any campaigns? Or if I just see a domain, even if it came back clean, that's like Speedy Passport, what the hell is that? I'll start cherry picking domains out if I see some in there that look off. And it's a great data source to get, is to pull your web proxy, and basically you've got a it's a tool that doesn't exist anymore, but there's Doug Song wrote a toolkit back around the turn of the century that you could run on a machine, and every time the browser went to an HTTP GET happened, it would extract out the URL and log it. And you basically have that running at the enterprise level if you've got a web proxy that you can feed into your SIEM, and then your SOC can start watching all of that data. Love it. Great thing to do in a sandbox. If you can do it across the entire enterprise, that's awesome data source for your SOC to have. Good.
Derek wanted to know how long the investigation took you.
How long this investigation took me when I first did it? A couple hours, maybe 3. And that largely because I was going slow to take screenshots and be careful with my notes, because I knew I was turning it into training afterwards. So I went a little slower than I would have if I was a SOC analyst doing it. But I think this only took me like 3 or 4 hours to get through the whole thing. And if I was in a SOC not taking notes and screenshots and writing PowerPoint slides at the same time, probably only about 2 hours is what it would have taken. Had I not wasted a bunch of time playing with the JavaScript and just dropped it into a sandbox and recorded the activity, that would have been cut down to minutes.
Nice.
The sandboxes, I did mention in there, you don't want to use the public ones if you don't want to tip the bad guys that you're on to them. That's a problem in a lot of incident responses. For a phishing email like this, I would check the Word doc and check the URL to make sure there's no victim PII on it. And then like what I did on this particular one, when I first passed through this as if I were the SOC analyst, and then went back and did it a second time, taking notes for the training. What I would do there is edit the Word doc to remove the victim PII and push it up to VirusTotal and see what it comes back as. Because they'll do additional analysis and find stuff that way. But the QR code had my email address embedded in the QR code. So there's a lot that would have had to change before I would have been comfortable sharing that one publicly. If you can get one of those sandboxes running locally, or you have a paid account on the sandbox so that your results aren't being shared publicly, then fine, just throw everything into it. If you run Cuckoo Sandbox or one of the other sandboxes locally in your environment, yeah, just fire every attachment into it and get that report back, and you don't have to worry about it being shared publicly if you're running the sandbox locally.
Nice.
Good. What's another good one here?
You just answered, Vincent. You said Cuckoo for a local one as an example. An online one might be like AnyRun or something like that, depending on what you need.
AnyRun is great. I'm a huge fan of Joe's Sandbox.
Joe's Sandbox
is expensive, but if you've got the budget, it's the reports it produces are beautiful.
Is it expensive relative to VirusTotal?
There is. If you pay VirusTotal, you can get you can upload and get scans back that are not shared publicly. And that's true for almost all of those sandboxes. There is a cloud-hosted version where they don't share it publicly if you've paid for an account.
Yep.
All right. Intezer's another good one. Yes.
Yeah.
What was Recorded Future? I did show a couple of doing DNS history lookups and such. I used to use a service for that all the time, and then that service was bought by Recorded Future, and now you have to pay for an account. So I wanted to show DNS history on when I look up those domains. DNS history is one of the things I always go to, but the slides I was deliberately trying to keep just free tools in the slides, so I didn't show that. But that is, if you can get DNS history on Recorded Future or one of their competitors, a beautiful resource when you're doing that analysis of an IP or a domain name. That is a wonderful data set to get. Hybrid analysis is Joe Sandbox. CrowdStrike has their own sandbox, but it's not hybrid analysis unless they're just using a different name. But if the domain name hybrid-analysis.com is Joe Sandbox. All right. Well,
Okay, Chris, that was
let's take a
amazing.
break.
Thanks for being here and taking all the time to do this and taking time out of your day to present
Yeah.
here at VetSecCon. This was awesome.
It's fun. I like hanging out with vets. You guys are fun.
All right, we're going to go on a break until 1:30 when we have Ron Warner up next. So go outside, touch some grass, get some sunlight, whatever you got to
Sure.
do. And we'll be back in a little bit. Thanks again, Chris.